Java is one of the easiest programming languages to learn, making it perfect for beginners. In this course, I'm going to walk you through programming in Java step by step. By the end of this course, you will create 2 real programs using Java, and you'll have a solid understanding of programming basics and fundamentals. I've been programming in Java since 2011, and I even used Java to create my own game server startup in 2014. I made a full-time income from this project for a few years before selling it. So I have a lot of experience using Java, and I'm looking forward to sharing my knowledge with you throughout this course. Before we can learn Java, we need a place where we can actually write and run our code. This is known as an IDE, which stands for Integrated Development Environment. That's just a super fancy way of saying it is a text editor that will also convert your code into an actual program. Now, the industry standard for IDEs in Java is going to be called IntelliJ. So you can simply just Google IntelliJ download. This is a free software. Go ahead and click on the top link right here. And make sure that you select Community Edition and that you also select the correct operating system that you're on. I'm on Windows, which is the default, so I'm going to stay here on the Windows tab. I can then click on Download. And your download should start, and on most browsers, you will have to agree that you want to download this file. Once it's done downloading, you can click on it right here. And here we have the actual installer. This is a pretty standard installer where you just click next around 800 times, and then you should be good to go. So I'm just going to go through and keep everything here the default. And then I'm going to go ahead and pause the recording while the installation is happening. After it's done installing, we can go ahead and click on this checkbox right here, and then finally click on Finish. Once you open it, you should be sent to a page similar to this one. You're going to want to click on New Project. Now on this page, you want to make sure you selected Java at the top. That should be the default. And for the project SDK, we can go ahead and select whatever the default is. But if you don't see a default, you can download a JDK. So we can click on this and you can select the version you want. Any version should do. We're not going to be doing anything that's very version dependent throughout this course. And just simply click on Download. Now, assuming you already have an SDK, we can just simply click on Next, and then Next again. And then finally, we can give a path to our project and a name. We can click on the 3 dots here to browse. I'm going to select my Java folder right here, and I'm going to create a new folder. This one will be called Workspace. And within here, I'm just going to select it and then click on OK. Now, the project name by default is Workspace. That's fine. I'm going to go ahead and click on Finish. And now IntelliJ is finally open. On the left here, we have this project, which we can toggle by clicking, and this is going to show all the files and folders within our workspace. Now, everywhere else in this giant panel right here is where our code will be shown, but we don't have any code open right now. But now that IntelliJ is successfully installed, we're good to go and start writing some code with the next video. We're now going to talk about arguably one of the most important concepts when it comes to programming, and that is the concept of variables. Now, you could think of a variable as basically a container that holds some kind of value. And your computer's RAM, or memory, is basically a bunch of shelves that hold these containers. Now, each container is going to have a name, and the value inside can be read or changed at any time. So for example, let's create an integer, which is basically just a whole number. I could say int, space, and now we have to name our variable. This should be something that is descriptive. We should not have variables named a or x or things like that that aren't very descriptive. So in this case, I want this to hold my current age, so I'm going to type age. So I'm naming this variable age, and you can name it basically anything you want, but there are some rules which I'll go over later in this video. Now afterwards, we're going to add in an equal sign, and then after the equal sign, we can add in any number. In this case, it'll be 28. And then finally, we have to add in a semicolon. So what is actually happening here? Well, the int is basically going to tell Java that we want to create a variable and that this is going to hold an integer type of value. There are different values that variables can hold, and we'll cover those later on in the video. Now, every variable needs its own name. In this case, we gave it the name of age. Afterwards, we have an equal sign, which is technically known as an assignment operator. This will take the value on the right and assign it to the variable on the left. And then of course we have the age, and you can add in whatever number you want here. It could be 999, it could be 0, it could be negative 5,000. Any whole number will work, but for simplicity, I'm just going to add in my current age, which is 28. So what can we actually do with this variable? Well, the most basic thing we can do is probably to print it out to the console. And instead of writing out system.out.println each time, IntelliJ actually gives us a shortcut because that is a rather long line of code to write. So I can type in SOUT for system out. If I press enter, it will automatically generate this line of code for us. Now it does not generate the double quotes, and that's intentional. If I were to add in the double quotes and then age, and I were to run this program, we simply see the word age in our console. But that's not what we want. We want to see the value inside the age variable. So we have to remove these double quotes so it will not display what's known as a string. A string is basically like a sentence or a collection of characters, something that makes up some actual text. Now without the quotes, it's going to try and reference the value inside of the age variable. In this case, it'll reach into that container I mentioned before, and it'll pull out the value 28 and then send that to the console. So if I run this again, we should now see 28 in the console like we do right here. So that's one example of what we can do with variables. We can also reassign a value. For example, let's say I have a birthday. I could say age equals 29 with a semicolon. And notice how I do not use the int right here. When I do that, there's an error. If I hover over it, it says variable age has already been defined. So basically, the int is only there when we're creating the variable. But after it's created, we can still change this value by reassigning a value just like this. Now to prove this, I can print this to the console. So SOUT, I could print out age, and if I run this, we now see 28 and also 29 right under it. So an integer is just a whole number, but there are various other types of variables. For example, if I delete all of this, I can now say string with a capital S, name equals Alex, and notice how I'm wrapping this inside of double quotes. If I were to just say Alex here, it would think that we're looking for a variable with that name, but there are none. So to tell Java that we're working with a string of characters, such as a sentence or a message, some type of text, then we're going to add in our double quotes. So Java will not look for a variable named Alex, but rather will treat this as a string of text. Now, of course, we can print this to the console. I can print out name, and if I run this, we will see Alex in the console. But there are many other variable types. For example, we have a Boolean, and a Boolean just represents either a true or false value. That's all it does. So for example here, I could say is programming equals true. Now true is not in quotes because that is technically not a string. True or false, which is the only other option for a Boolean, are technically keywords in Java, so we're able to just write them within our code. So for example, if this is true, I can now print is programming. Now if I run this, we should see true in the console. And of course, just like integers, we can reassign values to these. So I can say is programming equals false, and then if I run this, we're now going to see false within the console. Now I'm going to delete this line here, and you might notice how I named is programming. I have a lowercase I and a capital P. Within variable names, we cannot have spaces. So whenever we have multiple words, it is a common practice to use something known as camel case notation. Camel case notation is when a word is written with the very first capital letter being lowercase instead, but then every word after that has an uppercase letter at the start. This makes it very easy to read without any spaces. Compare that to camel case notation. This is obviously a lot harder to read, especially for other people who are just reading your code and didn't write it, so they don't know exactly what it is. Other rules involve that variables cannot have a name that starts with a number. Typically, you shouldn't do this anyway because it's not very descriptive. But if for some reason you absolutely want to, you can add in an underscore at the start, and it then becomes a valid variable name. As we move forward throughout the course, you'll see more examples of variable names so you can get a better idea of what is a good naming convention. So now let's move on to other variable types. Next, we have a char, which is similar to a string, but it represents only one single character. So for example, I can say letter equals A, and these use single quotes, not double quotes. If I were to add in multiple characters here, it's not going to like it and it's going to complain. So again, these only use single characters. We also have double, which is similar to an integer, but of course, this is going to be any number. It doesn't just have to be a whole number. So for example, age equals 28.5. This would be a valid double, but I'm using the same name as an existing variable, so I'm going to say age as double. That is another rule for naming, is that every name has to be unique. Otherwise, it wouldn't know which variable you were exactly referencing. Oftentimes when we have numbers, we don't just want to print them out to the console. we might want to add, subtract, multiply, or divide with those numbers. For example, I could say int number equals 50. And let's go ahead and start off by printing this to the console just so we can always see what's happening. Now I'm not going to run this because it's very obvious what would happen, but let's say we want to add 1 to this number. There's a couple different ways to do it. One example will be number equals number plus 1. Now if I run this, you're probably going to know what's going to be printed. In this case, it'll be 51. We can add 10 or 100 or any other type of value we want to this integer. Now there is a shorter way to do this. So I'm going to use control / to go ahead and comment out the current line. And then I'm going to say number plus equal to 100. Now this is basically the same exact thing as what we have right here. It is just a shorter way to add a number onto a variable. So if I run this, we're going to see 150 in the console. And we can do the same exact concept when it comes to subtraction. So instead of plus, I have minus. And if I run this, we're going to see negative 50 in the console. And of course, we have multiplication. So if I run this, here we see 5,000, and division, which is a /. If I run this, we're going to see 0. Now the 0 here is because we're using integers, which are whole numbers. If I were to change this int to a double, which allows decimal points, and I were to run this, we now see 0.5. And of course, all these symbols can be used on this original syntax. For example, we could say divided by 100 or times 100. Anything like that will still work. Now you might be wondering, why would anyone use this syntax here? Is because if you have multiple variables, then this is the only way to do things. For example, I could say int number 2 equals 10. Then I can say number equals number 2 times 100. We cannot do that with this type of syntax here, because this type of syntax is going to only modify the variable mentioned. In this case, that would be number. So now I'm going to delete most of this stuff, and I'm going to create another integer called number, and I'm going to set this equal to 5. Now let's say we want to add or subtract 1 from this variable. With what we just saw, we could do number plus equal to 1, and if I ran this, of course, this would work. We would see 6 in the console. But increasing and decreasing a number by 1 is so common that most programming languages, including Java, have a way to do this in an even shorter syntax. This is known as incrementing and decrementing a value. So I could say number plus plus, and if I save this, we're still going to see 6 in the console. This is going to increase the number by 1. And we can also do number minus minus. So if I run this, we're going to see 4 in the console because we're subtracting from the original number, which in this case is 5. Now, the pluses and minuses can go on either side of the variable, and they do slightly different things. In this use case, if I were to run it, we're going to see no actual change, and we're still going to see 6 in the console. But that's only because of how our code is written here. Having the pluses before or after will be much more clear on the difference if I add the pluses directly on the variable right here. So if I run this, we're still going to see 6 in the console. That's because the pluses before the variable name are first going to increment the variable and then use it. Using it in this case, we'll be passing it in to the print line function, basically printing it to the console. But if I were to add pluses afterwards, that means we're first going to use the variable and then increase it. So if I were to run this, we're going to see 5 in the console. But technically, in the memory of our program, number still holds the value 6. We just didn't print it. To prove this, I can print this out again. So I can print out number, and if I run this, we're then going to see 5 and 6. The same exact concept applies when it comes to minus minus. So if I go to run this, we're going to see 5 and then 4. Then of course, if I do minus minus before, we're then going to see 4 and 4. That's because we are first decreasing the number and then using it. And then of course, we're just printing out the results again. As we move forward through the course, you're going to see a number of different ways and instances where this is going to be useful to use, especially when it comes to our first project, which will be around halfway through the course. We're now about to dive into a very important concept known as control flow. Control flow is basically where we get to control the flow of the program. Who would have guessed? And this is most commonly done with something known as if statements. Basically, if something equals something, then we're going to run a certain piece of code. Otherwise, we might not. Think of your favorite shooting game. If you press the reload button, it's going to check if you have a full magazine or not. If you do, it's not going to reload. But if you don't have a full magazine, it will then reload. Let's start off by creating some user input. So I can create a scanner. I'm going to call this input, and I'm going to assign the value of new scanner, passing in system.in. And now that we have access to this input object, we can actually read input from the user. So I'm going to say int number equals input.nextInt. Now I'm going to just simply print this out to make sure everything is working all right. I can run this with Shift and F10. And here it's expecting me to enter a number. I'm going to enter 50, and then we get 50 printed back, so everything is working fine. But instead of just printing out the number, I'm going to use an if statement. So the syntax for an if statement would be if, parentheses, and then a curly brace, and an ending curly brace on the next line. Now, inside the parentheses is where our condition goes. And this condition is going to be typically comparing two things. So for example, I could say number, 2 equal signs, 50. Now the 2 equal signs is very important because a single equal sign, as I mentioned before, is an assignment operator. This will take the value on the right and assign it to the variable on the left. But 2 equal signs is a comparison. This is going to see if the value on the left equals the value on the right. So I'm going to add in a comment here that says comparison. Now, what happens if these two things are equal? Well, this will basically become a Boolean expression. And if you remember before, a Boolean equals either true or false. There's no other values a Boolean can use, and all if statements and any type of conditional like this is basically going to look for a Boolean value. So hypothetically, let me comment this out and let me just enter in the number 50. Now in this case, our text editor gives us this yellow warning. If I hover over it, it says condition number equals 50 is always true. Now obviously that's the case because our value right here is 50 and that's never changing. Now the important part here is that it is always true, which is a Boolean value. So this is basically the same thing as saying if true. Now if this is the case, then the code inside these curly braces will always be ran. If this was false, then the code inside the curly braces will never be ran. So the condition inside the parentheses must be a true condition. So I'm going to use Control Z to backspace up until here where we're actually receiving user input. And within here, I'm going to simply print to the console saying the number is 50. Now I'm going to get rid of some of these comments here just to make our code a little cleaner. And I'm going to try running this with Shift and F10. And here it's expecting me to enter a number. If I enter 50, it's going to say the number is 50. And if I run this again and I enter anything else, for example, 99, it's not going to print anything because this condition is false. Therefore, the code inside will not run. But what if we want to check other numbers? Well, in theory, we could just add a bunch of if statements. For example, number exactly equals to 51. But what if we only want one thing to be printed to the console? Now, every time we create an if statement, this is going to create something known as an if statement chain. So an if statement chain, and this is going to contain up to 3 different types of statements. We have our if statements, we have our else if statements, and we have our else statements. So let's take a look at else if statements. If I get rid of this if statement here, I can then say else if number is exactly equal to 51. I can then print out the number is 51. Now an else if statement has to be directly after an if statement. And these will basically look at all previous if and else if statements. And if they're all false, then it will go ahead and try and compare these two values. So in this case, we get to our if statement on line 16. It's going to compare number to 50. If that is true, we are then going to run this code. And then we're going to jump down to right here. We're not going to actually even try and compare the number to 51 because the else if statement sees that the if statement was true. So it sees that there's no point to even check the two values. But if we entered a different number, for example, 51, this condition is now false. The else if statement will see that and will then try and compare these two values. In this case, the two values are the same, so this code will be ran. But if I enter 52, nothing here will be ran. To prove this, I can run our program. I can enter 50, and here we see the number is 50. If I run it again, I can enter 51, and here we see the number is 51. And finally, I can run it and I can enter 52, and nothing happens. Now for each if statement chain, for example, this right here, we can have only one if statement, but as many else if statements as we want. For example, I can say else if number is exactly equal to 52. I could then print out the number is 52. And to make things a little more interesting, I can say else if number is exactly equal to 52 again. I can then print out test just to make sure that this print statement is very different than the others. So if I run this and I enter 52 in the console, we now see the number is 52, but we do not see test. That's because this condition here was true. Therefore, this else if statement is not going to even bother comparing these two values and will certainly not print out anything within the curly braces. Now, of course, our IDE is complaining because these two things should not actually be here. This statement here will actually never be ran no matter what, because if the number is 52, then this code right here on line 21 will be ran instead, because our condition on line 20 will be true. So this has to be at the very end of an if statement chain, and this is basically just a catch-all if nothing else in the if statement chain was true. So for example, I can print out unknown number, and I can run this, and if I enter 50 through 52, we know what's going to happen, but what happens if I enter 53? It says unknown number because all three of these if statements right here are false, therefore the else statement will be ran. But if I were to run this and I were to enter 52, then it says the number is 52, and the else statement is not ran because it sees one of the previous if or else if statements were true. Basically, the program is going to go through all of these and try and find the first true statement and ignore all of the rest. In the last video, we had a look at if statements, but that is just one example of control flow. Another example is going to be something known as a switch statement. Now this is less commonly used as if statements, but you will see it from time to time, so it's important to understand how it works. So I can simply say switch, parentheses, and then curly braces afterwards. Now inside these parentheses is going to be a value, not necessarily a condition, but any type of value, for example, in this case, a number. Now inside, we're basically going to have something known as case statements, which are kind of like if statements. So I could say case 50 with a colon. If I press enter, I could then add in the number is 50. And then I have to add in something known as a break statement. So I'm going to go ahead and run this with Shift F10. And within here, I can enter the number 50, and it's going to say the number is 50. Now, if I run this again, and I enter anything else, for example, 51, nothing's actually going to happen because obviously we're not handling 51 anywhere. So this is slightly different than an if statement, and it has its own use cases. It's actually most commonly used from my experience when comparing strings, but you can use it instead of if statements if you really wanted to, but there's more to this. For example, I can add in more cases, so case 51. I can then add in the number is 51, and I can break. Now, of course, if I run this and add in 51, it will just say that. But what happens if I want to check for two different numbers? Well, I can also say case 52, and then the print statement will say the number is 51 or 52. Now, if I run this, I can then go ahead and enter in 52, and it says the number is 51 or 52. Of course, we'll get the same output if I enter the number 51. Now, the ability to check two different values with an if statement will be explained in a few videos in the course. It's much easier to explain that with switch statements, so that's why I'm covering it here. And one thing to keep in mind is that basically if any of the cases are true, the code will continue to run until a break statement is found. For example, I can change this to the number is 52, and then I can print out the number is 51 right here. And notice how we do not have a break statement after this print statement right here. This right here is the only break statement we have for 51 and 52. So if I run this and I enter 51, what's going to happen is it will continue to run the code until it finds a break statement. So we see the number is 51. It doesn't care if there's a case here. It's just going to ignore that. And it's going to run this line right here. The number is 52. And then we're going to break. Now, one last thing for switch statements is going to be default, which is something that typically goes at the very end. And this is kind of like the else statement for if statements. So here I can print out unknown number. And technically you don't need a break statement, even though a lot will argue it is proper syntax. But the code will work just fine even without a break statement, because of course default should be the very last case that you check within your switch statement. So if I go ahead and run this and I enter any other number, for example, -500, we then see unknown number. So switch statements are fairly simple and they can be used instead of if statements in some use cases, but typically you're just going to be using if statements. We're now going to jump back to if statements and take a look at comparison operators. These are different ways that we can compare two values. Previously, we had to look at double equal sign, which will just simply check the value on the left and compare it to the value on the right. But there are many more operators we can use within Java or pretty much any programming language. For example, we have a greater than sign, we have a less than sign, we have greater than or equal to, and we have less than or equal to. And we also have not equal to. Now, most of these are very self-explanatory, but let's take a look at some examples. I can say if number is not equal to 50, I can then print out the number is not 50. And if I run this and I enter 50, of course, we're not going to see anything because the number does equal 50. Therefore, this condition right here is false. But if I run this again and I enter anything else, for example, 1, we see that the number is not 50 because, of course, 1 is not the same thing as 50. Now let's try some other things. For example, I can say number is greater than 50. I can now say the number is greater than 50. And if I run this, I can now enter whatever number I want. For example, 900, and it'll say that the number is greater than 50. But if I enter anything less than or equal to 50, then nothing's going to happen. And the equal to part is important because 50 is not greater than 50. It's equal to it. So if I enter 50, nothing's going to be printed. If I wanted that functionality, I can say greater than or equal to 50. So if I run this and I enter 50, of course, we're now going to see the number is greater than 50, but that's just because I did not update this text. But the important part here is that number is now greater than or equal to 50. And of course, the less than operators will work the exact same way. I'm sure you can imagine how those will work. And we can use these to have more complicated expressions within our if statements to then have more complex and more meaningful programs. Let's have a look at logical operators. These are other ways to add in more complicated checks within our if statements. So a few examples of this will be the not operator. This will also be the logical and operator and the logical or operator, which is by holding shift and pressing the key above enter. So the not operator is going to basically just reverse a value. The and operator will basically make sure the thing to the left and the thing to the right are true. And the or operator will make sure the thing to the left or the thing to the right or both are true. So let's take a look at all of these with examples. I can say if number is exactly equal to 50 or number is exactly equal to 55. I can then print out 50 or 55. And if I run this, I can now enter 50 and we see 50 or 55. Running this again, entering 55, we see the same thing. And of course, if I run this and I enter anything else, for example, 70, we don't see anything in the console. So basically, this wants to see that the left side of the or operator or the right side or both are true. And it might be obvious because this is the logical or operator. Let me go ahead and add in what these stand for. So the logical or operator is going to be this or that, either one. Now the and operator won't make too much sense in this use case because the number variable cannot hold 50 and 55 at the same time. A better example of the and operator is when using greater than and less than. So for example, I could say number is greater than or equal to 50 and number is less than or equal to 55. So anything from 50 to 55 should be included. So I'm going to change this to 50 to 55. And if I run this, I can now enter 52 and we see that this is true. So essentially, if the number is greater than or 50 and the number is less than or 55, then the entire if statement will be true. If either of these two expressions are false, then the if statement will be false. For example, if I run this one more time and I enter 56, nothing's going to actually happen. While this part right here is true, because 56 is greater than or equal to 50, it is false right here because 56 is not less than or equal to 55. And the and operator requires both the left and the right to be true. Now let's take a look at a not operator, which is basically just going to reverse a Boolean expression. So within if statements, we can actually pair certain conditions together. For example, I can wrap a parenthesis around this entire thing. And if I were to run this, the same thing would happen, but now we can use a not operator right beforehand. So this entire expression will be either true or false, depending on what the value of number is. And the not operator is simply going to reverse that. So I'm going to say not 50 to 55. If I run this, I could then enter 52 and nothing happens. But if I run this again and I enter anything that is not between 50 and 55, for example, 34, we see not 50 to 55. So the not operator is going to simply just reverse a Boolean expression. And throughout the course, we're going to see more use cases of the not operator and the other two operators as well, and how useful they can be. We're now going to look at the most simple example of a loop. And this is a way to make certain pieces of code continue to run again and again, as long as we want them to run. So there's a few different types of loops, but in this video, we're going to take a look at the while loop. So we can say while, parentheses, and then curly braces. And inside this condition is going to be a Boolean expression. This is going to be either true or false for if this loop should continue to run. For example, I can make an integer called counter and set this equal to 0. I could then say while the counter is less than 10, I can then go inside of the while loop and everything inside the curly braces will be ran as long as this condition right here is true. Now currently, this would be known as an infinite loop because counter is never changing. It's always 0. So counter less than 10 is always true. We want to make sure that we actually change the state of counter where it being 10 or greater is a possibility. That way, we don't get stuck in this loop forever. So to do that, I'm going to first print out what counter is. So I can say counter, colon, space, and then outside of the string, I could do plus counter. This will add on the contents of the counter variable onto the overall string that is then passed in to the print line function. Now afterwards, I can say counter plus plus, or if I really wanted to, I could put this right here. As we learned before, putting the plus plus to the left of the variable name will first increase it and then use it. And using it in this case will be printing it to the console. So before I run this, let's go over what I just did. I created an integer variable with the value of 0, and we're saying while that variable is less than 10, we are going to run all of the code inside of these curly braces. Now this code simply just prints out counter, but before we actually print out counter, we're going to increase it by 1. This means that our loop is no longer infinite because the first time this runs, it'll print 1, then 2, then 3, and so on until it gets to 10, where counter less than 10 would no longer be true, so we can then break out of our loop and continue with the rest of our program. So let's do this in action. I can do Shift F10, and this should run our program. And if I expand this window, we now see counter 1 all the way through 10. So this is a very simple example of a loop. Basically, while this is true, we are going to run all the code inside of the curly braces. Let's now take a look at the do while loop. This is similar to the while loop, but is slightly less commonly used. So the syntax for this would be do, then curly braces, and then at the ending curly brace, we would say while with our parentheses and a semicolon. Now the condition is going to be put inside of this right here. Basically, the concept here is we are going to run this block of code immediately, no matter what, and then afterwards, it's basically just going to become a normal while loop. We're going to continue to run that block of code while this condition is true. But no matter what, this block of code will be ran at least once. That is different than a while loop, where this block of code is only ran, even the first time, only if the condition is true. Now, a practical use case for this is receiving user input and making sure we get the correct type of input, or a correct number, for example. So I can say scanner, input equals a new scanner. I can pass in system.in, and then here I'm going to say int number. I'm not going to assign a value to it, and that's something we can do with variables. We can create them, but we don't have to assign a value to them immediately. Now inside the do block of code right here, I'm going to say number equals input.nextInt. And then I'm going to say while number is less than 10. So essentially what this code is going to do is we're first going to receive some input from the user. We're going to create a number, which we're going to use later on. And then we're going to run this code no matter what the while condition is. It always runs once. So essentially, we're going to receive input from the user, ideally a number, and then we're going to continue to run this as long as this condition right here is true. So therefore, we have to provide a number that is 10 or more in order for it to actually receive valid input. Now afterwards, I'm going to print out the number, and I'm going to run this with Shift and F10. Now inside of here, I can enter whatever I want. For example, 5, 4, 7, anything less than 10 will be completely ignored because the while loop will continue to make this block of code right here run over and over again until this condition is false. I can even enter -5,000, for example, and it's still going to continue to work. But as soon as I enter anything 10 or greater, for example, 84, it's going to break out of that loop and it's going to print 84 right here. Let's take a look at the most powerful loop, which is known as the for loop. This is the best way to count things or to iterate over a list of certain elements. Now that might sound confusing, but over the course you'll see examples of that. For now, let's just simply try counting something. In a previous example, I created a counter and then used a while loop to go ahead and count over that. But we can use a for loop to achieve this in a much cleaner way. For example, I can say for, parentheses, curly braces, and inside the parentheses, there's going to be 3 different elements that are going to be separated by semicolons. So the first one is going to be the initialization. This is where we can actually create variables that can be used within our loop. One is going to be a condition similar to a while or a do while loop. This will be if the loop should continue to run. In this case, I'm going to say counter less than 10. And then afterwards, this last section is going to be code that we ran every single time the loop completes. So in this case, we want to say plus plus counter. So each time we're going to increase counter by 1. Now within here, I'm simply just going to print counter to the console. And if I run this with Shift and F10, we should see a count from 0 to 9, as we see right here. So when the loop first starts, it creates this variable only once. It then sees if this condition is true. If so, it then runs all the code within our curly braces here, simply just prints 0 to the console as we see there. Then once it gets to the end, it realizes there's nothing left to do, so it goes to loop back. As it's doing that, it increases counter here, and then it notices that counter is now 1. 1 is less than 10, so it keeps repeating the process until this condition is false, which we see right here because once it's 9 and it increases to 10, the condition is no longer true, so therefore we break out of the loop. Let's take a look at the break and the continue keywords. We've had a look at break within switch statements, and it works kind of in a similar way here, but these are 2 keywords that can be used within any of the loop types. So for example, I could say int counter equals 0, while counter is less than 10. Now in here, I'm first going to increase counter, and then I'm going to print it to the console. But let's say that I want to skip the number 5. After I increase it, but before I print it to the console, I can say if counter is exactly equal to 5, I can now continue. And continuing will basically just skip everything else in the loop and just go back to the start of the loop. It will still check the condition, but everything past this continue statement here will basically be ignored. In this case, it is just this line here. Essentially, once we hit this, we're just going to jump back up to the start and then continue looping normally from there. I'm going to press Shift and F10 to run the code. And here we see 1 through 10, and now let's take a look at the break keyword. And some of you might already guess what this is going to do. Essentially, instead of just jumping back to the start, it's just going to break out of the loop entirely. If I run this, we see 1 through 4, because once 5 is reached, it's immediately going to break and start running the code outside of the while loop. So you can use these 2 keywords to have better control over your loops and what is executed and when to break out of them. And both these keywords here work on every loop in Java, including the 3 types we've seen so far. Let's put all the skills we've learned so far into use. Let's make our very first project, which is going to be a simple calculator. Now, most of the things you've learned so far will be directly applied inside this project, but this project is designed to still be difficult if you were brand new to programming when you first started this course. So if you run into any problems or you're struggling with this project, that is expected, and don't worry. There's three main things I want to do when it comes to this video. The first one is going to be going over a plan. When designing any program, even just a simple calculator, it's important to have a plan and an overall idea of what you want to do before you start writing code. The second thing is I want you to try on your own. So I'm going to show you step by step how I would make this. But before I do that, I want you to pause this video and try making it on your own after we go over a plan. While courses like this one help, the best way to get better at programming is to just write code. So I highly encourage you to get as far as you possibly can on your own before you watch how I would implement this. Now the third thing is going to be, I will show you how I made this program. So after we've designed our plan together, and after you try to make this on your own, I'm going to show you how I would make this program. So let's start off with step one, going over a plan. What should this project do, and what do we need to do in order to achieve that? Well, the first thing is it should ask for two numbers, and then it should ask for a math operation. This will be a plus, minus, multiplication, or division. So it'll be one of these four characters. Afterwards, we need to display the result and then loop back to the start of the program where we ask for numbers. So this is a very, very basic plan when it comes to this project. Some of these things should be simple, other things will require you to think, perhaps even going back to previous lessons. So again, try and pause this video right now and get as far as you possibly can on your own, and then come back once you've completed the project or once you want to make this program. Okay, so hopefully you've already tried on your own. Now let's go ahead and implement each one of these steps. But our plan here shows an important use of reading all of the instructions. For example, here we see loop back to the start of the program. So that means that this entire program could be inside of a while loop. So I can say while true. And now this will be an infinite loop that will run forever, which is fine for this use case. Now it's going to say it should ask for two numbers. So I'm going to start off by making a scanner, calling it input, and setting this equal to a new scanner, passing in system.in. Then I'm going to print out enter the first number, and then I'm going to say int number1 equals input.nextInt. So far we've asked for one number. Let's basically do the same exact thing for the second number. So I'm going to print out enter the second number, and then I'm going to have another integer, so int number2 equals input.nextInt. So far the very first step is done. We now have the two numbers. Now we should get a math operation. So plus, minus, star, or forward slash will be addition, subtraction, multiplication, or division. So next, let's tell the user what to do. I can say enter an operation, and then we're going to say what options there are. So plus, minus, star, and forward slash. And then I can say string operation equals input.next. So now we have access to both the numbers and the operation we want. Now using if statements for comparing two strings does not work correctly with everything I've taught you so far. So with that said, we're going to be using switch statements here. So I can say switch operation. I could then say case with a plus, going to add in break, and then I'm going to say case minus break. I'm just going to go ahead and add in all four of these. So we have case star, break, case forward slash break. Now, in order to get a result in all of these, I need to create it outside of this curly brace. The details of why that is will be explained in a future video. So I'm going to create an integer called result. I won't assign a value yet. We're going to do that inside of our switch statement. So if they entered a plus, I'm then going to say result equals number1 plus number2. Also make sure you spell number correctly. And then for minus, I'm going to say result equals number1 minus number2. For multiplication, I can say result equals number1 times number2. And then for division, I can say result equals number1 divided by number2. So now outside of the switch statement, I can then print out the result. So I can say result, space, and I can add on the results right here. Now here we're actually getting an error in our IDE. If I hover over this, it says variable result might not have been initialized. We can go ahead and click on initialize variable, and it's simply going to assign 0 right here. Even though we're going to override that value, it still likes to see that we're going to have a default value because it doesn't know for sure if one of these 4 cases will be ran. So let's go ahead and run this and let's see what happens. If I press Shift and F10, it's going to say enter the first number. I'm going to enter 5, enter the second number, 3, enter an operation. I'm going to enter multiplication. The result is 15, and now it loops back and says enter the first number. So for example, I could do 10 and 5 and then subtraction, and here we get 5. So it's going to keep looping over and over again and keep asking for the first and second number, and we can then do any type of operation we want with those numbers. Now keep in mind that we are using integers here, so if you try division, it is only going to give you whole number results. If you wanted a more accurate results, you can use double instead of integer for the result variable. Now, if you completed this program on your own, then congratulations and good work. But if you needed to watch some of the extra video in order to do it, don't worry, that's perfectly fine, especially if you're new to programming, because this is a brand new skill. As you move on through the course, more things become more apparent to you and easier for you. It just takes time to learn all of these things. This is where things start to get a little more complicated, but also more fun. So this next topic is about methods. And methods are basically just a block of code that are ran, and their goal is to do one specific thing. In fact, we've been working in a method this entire time. This main method right here is ran by default whenever we run our own program. But we can create our own methods. So outside of the curly braces for the main function, I can say public, static, void, example, parentheses, and then curly braces. And in here, we can write whatever code we want. For example, I can just simply print out hello world. And then in our main method, I can say example, and it'll automatically know we're trying to run this function. So if I press Shift and F10, it should run our program. And here we see hello world in the console. So a lot is happening here. And I also have mentioned methods, and I've also have mentioned functions. And functions are practically the same thing, although there is a slight difference. A function is basically what we see right here. This is technically a function, and so is this. But whenever a function is inside of a class, which I'll explain in a future video, these are now called methods. But in most cases, it won't matter. They're interchangeable for the most part. But technically, a function is outside of a class, and a method is inside. Now again, we'll cover classes in more detail in the future. For now, just think of them as a container where all of your methods can sit in. So adding these parentheses here will invoke or run or fire this function. These are all interchangeable terms, basically of a way to run the function. Those are also common terminologies that are used when we're actually trying to run a function. Now you might be wondering, why call the example method when we can just print hello world in the main method? Well, that's because this is obviously an oversimplified example, but in a real program, you may not want to just use this example function once. You might want to use this example function multiple times throughout your class or even throughout your entire project. So having the ability to abstract certain pieces of functionality into their own methods makes it much easier to reuse that functionality. We'll see this in real examples as we move forward through the course. But now let's explain what these parentheses are and also what this void means right here. Basically, a function can receive input and it can also return input. So I'm going to get rid of these comments, and if I click on the example name and I press Shift and F6, I can now refactor or rename this entire function. So I can say add. If I press enter, it renames the function as well as the function invocation. Now inside of the parentheses, we can add in something known as parameters. For example, I can say int num1 and int num2. These are separated by a comma. We can even have multiple types of variables, for example, string example, but in this case, we're just adding 2 numbers, so there's no need to have a string here. Now, automatically, IntelliJ gives us this red error here, saying that we cannot call it without any parameters. So we can pass in some information here, for example, 5 and 10, and now we no longer have any errors, but this code does not work as we expect it to. That's because we're still just simply printing hello world, but what we want to do is we want to return the sum between num1 and num2. So I can say return num1 plus num2. Now we get this error here. If I hover over it, it says cannot return a value from a method with a void result type. So this void right here means nothing is going to be returned. But we have to be very clear what type of data will be returned from each function. So in this case, we're returning an integer because we're adding two integers together. So we could change void to int and the error goes away. Now over here, I could say int sum equals add 5 and 10, and I can print out sum. And if I run this with shift F10, this will print 15 to the console. Now, if we wanted to, we could also just pass in this function call inside of the println function. And in fact, println has been its own built-in function that we've been using this entire time. It has its own parentheses, and we're passing in information to it, just like we are with this add function. And here's a perfect example of why we want to make functions, because I can copy and paste this a couple times, and I can now add in different values if I wanted to. This now gives us 3 different results of 15, 20, and -3. And it's all because we have this simple add function right here. Now, obviously, this is a very simple function, but if we had more complicated functions with more code inside of them, you can see the benefits of having to only write the code once and then running that from different places as many times as you want it. Now, one last note is that these here are technically called parameters, but when they're passed in, such as right here, or these numbers directly, these are known as arguments. So you have parameters and arguments. And just like functions and methods, these are often used interchangeably, but technically what you write in the function itself is known as parameters, and what you pass into the function is known as arguments. But again, just like functions versus methods, they're often used interchangeably. In the previous video, we created a simple add function that returns the sum between two numbers. But what if we want to add strings together to create a sentence? For example, I can print out add hello and world, and obviously this doesn't work. But of course, I could print out add 5 and 5, and this would work. Now, typically, you can only have one method with the same name similar to variables, but we can do something known as method overloading. This basically means having multiple methods with the same name, but different parameters and different return types. For example, I could say public static string with a capital S, add string S1 and string S2. Now within here, I can return S1 plus a space plus S2, basically putting the two words together. Now we have two methods that have the same name, but we have overloaded them where Java is now going to know which one to call depending on the parameters passed in. So on line 5, we're passing in strings, so it's going to call the method here. And on line 6, we're passing in integers, so it's going to call the method here. I can go ahead and run this and we'll see the output. Here we see hello world and 10. Method overloading is often useful in situations like this where you have similar functionalities, but you want to pass in different types of variables. And so you can overload those methods, basically cloning them and having different parameters and possibly a different return type if it makes sense to. Every time we create an opening curly brace, such as this one right here, it's creating something known as a scope. And the scope is going to limit what can and can't use certain variables. For example, I can say int counter equals 0, and then I'm going to create a while loop to increment this counter. So while counter is less than 10, I can then say counter plus plus. Now we can access this counter perfectly fine, so I can print it right here, and everything works as expected. But what happens if I create a second variable inside? So for example, I say int example equals 15, and I go to print this out for whatever reason. Obviously, it doesn't make too much sense, but this is just an example. Everything works so far, but what happens if I try and access example outside of the while loop scope? So I could try printing this out. I can add in example, and we get an error here. If I hover over this, it says cannot resolve symbol example, and it even has a solution here where I can click to bring the int example into the current scope. So note that example is created on line 14, writing the variable on line 9, which is inside the main function scope. This means everything inside the main function can use it, including the while loop's own scope, because that is also inside of the main function. So it has changed our code to simply just reassign example with the value 15, but we're creating it outside of the while loop. Now, even with all of this said, it's not a good idea to just simply blindly put all of your variables at the top of your function. For example, let's say that I am not printing out this variable here on line 20. In this case, the example variable has no need to be defined in the main scope, and instead, it could be just simply defined in the while loop scope. So I could say int example, and then I can get rid of the variable creation right here. Typically, unless you have a good reason to, you should always define your variables as locally as possible. By that, I mean right here, this is as locally as possible because we are using the variable on line 16, so it is going to be local to the scope right here. There's no need to define it outside in the main scope because right now with this code, we're not using it inside the main scope at all. We're just using it inside the while loop scope. Sometimes you might want to write an if statement, but in a more condensed way. This is often the case whenever you want to have a single value that you're assigning to a variable depending on a true or false statement. We can achieve this with something known as a ternary operator. And this is basically going to be some type of condition followed by a question mark, then a true value, a colon, and then a false value. Now this might seem confusing, so let's take a look at a real example. I'm going to create a Boolean called isMember and set this equal to true. This might be if you're paying for a membership somewhere and they offer a single one-time payment, they might give you a discount on that purchase. So for example, here I can say int price equals isMember. Now again, this is our condition, and a condition is just a Boolean expression, so a simple Boolean statement will work just fine. So question mark, and then we have our true value. So in this case, the price might be $10, but let's say that we want to charge a higher price for people who are not already members. So I can add in a colon, and then the price here could be $40. Now I can go ahead and print out the price here, and I can run this with Shift and F10. And here we see 10 in the console. But if I change isMember to false and I run this, we are then going to see 40 in the console. The reason for this is now this condition here is false, so it's going to use this code here, which is part of the false value. Anything after the colon is going to be used if the condition is false. Anything before the colon is going to be used if the condition is true. Now obviously we could do something similar to this. If I say int price equals 0, then I can say if isMember. I can now say price equals 10, else price equals 40, and this will work in the exact same way. But a ternary operator really shines here whenever you're using very simple if statements where you want this to be on a single line of code, because obviously writing this one line of code is much easier than writing all of these. Let's now talk about arrays, which are basically just a collection of variables. As an example, let's say I have a number of different student test scores. I can say int student 1 equals 96, int student 2 equals 49, int student 3 equals 76, and so on and so on. And let's say I have a bunch of these. Well, I don't want to necessarily create a bunch of different variables. Instead, I can create one variable, which is known as an array. This is basically going to be a collection or a list of a bunch of different variables. So I have to first specify what type of variable the array is going to hold. Each array can only hold one single type. You cannot mix and match them. For example, you cannot have an integer with a string. They all have to be the same exact type. So I can say int, opening and closing square brackets. This represents an array. I could then say student scores equals a new int with the square brackets as well. And this is going to create our own array. But whenever we're creating an array without initial values, which I'll show you an example of here in a moment, we do have to specify how many different types of elements we want to make room for. In this case, I want to make room for 3. And so now I have created an array that can hold up to 3 integers. To assign a specific value, I can say student scores, square brackets, and in here is where we specify something known as an index. This is basically just a counter for which exact slot we're going to use out of the 3 we're given. And this starts counting at 0. So I can say student scores index of 0 equals 96, student scores index of 1 equals 49, and student scores index of 2 equals 76. Now I'm going to go ahead and get rid of these three integers right up here. And now I want to print out each one of these to the console. So to do that, we can use a very similar syntax to this. So I can print out student scores index of 0. And I'm going to go ahead and copy and paste this using Control-C and Control-V, or Command-C, Command-V on a Mac. And now I can change these indexes to 1 and 2. Now I can run this with Shift and F10. And here we see all three numbers. But what happens if I try and access index 3, which doesn't actually exist? And in fact, we get this little warning right here. If I hover over this, it says array index is out of bounds. So if I go to run this, we're actually going to get an error in our console, and this is known as an exception. An exception is something we'll take a further look at in the future, but for now, just think of it as an error. And the reason why we got this is because we're trying to access something that the array does not have room for. We only assigned space for 3 integers in this array, and we have used all 3. Again, remember, it starts counting as 0, so the 3 spots we have are 0, 1, and 2. So therefore, index 3 cannot exist, and this is trying to access something outside of the boundaries of this array. So one more example I want to show you is how to create an integer by setting specific values when creating it. So instead of specifying 3, we can delete this, and then after the square brackets, we're going to create our own curly braces. And here we can add in any number of elements we want. For example, 96, 49, and 76. And now we have these warnings here. If I hover over it, it says a variable is already assigned to this value. So essentially, these 3 lines of code here are not necessary whatsoever. If I delete them and I run the program again, we're going to get the same exact output, as you see right here. Now we can have arrays for any type of variables. For example, we can create an array of strings or an array of booleans, but this is a very simple example with integers. And one last thing I want to show you is how to access the length or the number of elements within an array. And one last thing I want to show you is how to access how many elements or how many items are inside of an array. So I can print this out. I'm going to access student scores dot, and here we can access length. This is going to be an integer that is going to say how many elements are inside of this array. So I can go ahead and run this. And here we see the number 3 because there are 3 elements. If I added an extra one here, I can then run this one more time and we should see 4, as we do right here. Now, of course, we don't see the 100 printed to the console because we are not printing index 3, which now exists thanks to this 100 right here, but we are only printing the initial 0 through 2, so the 100 is not displayed to the console. In the previous video, we had a look at how to create arrays and also how to access each individual element. But what if we had a larger number of integers and we don't want to manually print out each one? Well, we can use a standard loop or something known as a for each loop to go ahead and loop through each element here. So I will show you 2 examples. Here we have a standard for loop, and I'll also show you a new concept, which is a for each loop. But first, we have a standard for loop. So I can say for, parentheses, curly braces, and inside, I'm first going to create my own integer. So int counter equals 0, while the counter is less than student scores dot length. We can then increase counter, and then in here, I can simply print out student scores index of counter. So we can pass in variables as an index here, and this will access index 0, then 1, then 2, and so on until we loop through every single element of this array. To prove this, I can run this with Shift and F10, and here we see all 4 numbers in our console. Now, looping through arrays is so common that they made a shorter syntax. So I'm going to comment out these 3 lines, and here I'm going to use something known as a for each loop. So I can say for int number colon, and then the name of our array. In this case, student scores. And now within here, the number variable is going to hold each individual element as it loops through them. So on the first iteration of this loop, the number variable will hold the value 96. The next time it loops through, it'll hold 49, and so on. To prove this, I can print out number, and I can run this with Shift and F10. And here we see the same exact output. Now, typically a for each loop will work, but in some use cases, you might need access to the index that you're using. For example, this counter variable right here. In those situations, you can simply just use a standard for loop, but again, in most situations, the for each loop will be just fine. Now that we have a better understanding of arrays, we can tackle a concept known as var args. which is a different way to pass in as many different parameters as we want into a function. So I'm going to make a very simple add function. I can say public static int add, and here I can have int num1 and int num2. Within here, it's very simple. We just simply return num1 plus num2. Now, to make sure everything works, I can print out add, passing in 10 and 15, and I can run this with Shift and F10. And here we see the sum as 25. So everything seems to be working. But what if I want to add on another number here, or multiple different numbers, as many as I want? The problem here is I have to now add in an individual parameter for every single input, and the number of inputs could possibly change. Well, the concept of varargs solves this. We essentially can pass in any number of integers into our parameters. So for example, I could say int 3 dots and then nums, or numbers, whichever one you prefer. And numbers is essentially going to be an array. So with that said, we no longer have access to num1 or num2. Instead, we now need to loop through each individual element of this array. So I can say int sum equals 0, and then I can return sum. But before we return, we need to actually add on every single number to the sum. So I can use a standard for loop, or I can use a for each loop. So for int number colon numbers, and then I can say sum is plus equal to number. So now I can run this, and we should see the sum of all of these numbers right here, and it's going to print out 10. Now, one thing to keep in mind is that varargs need to be the very last argument, because if we had additional things here, for whatever reason, let's say we have a student int. So if we have additional arguments, then we'll need to add them before the varargs. The vararg should always be at the very end, so it knows where they start, and it knows that every further parameter passed in is going to be accessed as that vararg. For example, 10 here is going to be students, and it actually identifies that right here. But any additional numbers here, such as 5 and 15, are now going to be part of the varargs parameter. Sometimes you might not want your variables to change values, and also sometimes you might want to change the type of variables that your variables are. Let's start off by taking a look at something known as constants, and this basically means that a variable value cannot change. So if I say string name equals Alex, I can print this out to the console, and of course, before I do so, I can actually change this to my full name, which is Alexander. But let's say hypothetically I don't want this value to change. I can add the final keyword before we create our variable, and now I get an error right here. If I hover over this, it's going to say that you cannot assign a value to a final variable. Now you might be wondering, why would you want to do this? Why not just simply not change the value of the variable? And that might be the obvious solution when it comes to a simple program such as this one, but in real programs where you have hundreds of files, hundreds of thousands of lines of code potentially, and potentially even other coworkers, you might not remember everything your code does, and you also might not remember that certain variables might have side effects if you change their values. So if you're going to have a variable whose value should not change, then you should make it a final variable with this keyword here. Now next, I'm going to show you something known as casting, which is basically where you can take a variable and assign it to a different variable of a different type. For example, I could say int amount equals 10, and I can then create a double which holds a decimal value, so therefore we can have non-whole numbers, and I can say new amount equals amount. Now if I go ahead and print out new amount and run this with Shift and F10, we now see 10.0. And in this case, we don't actually need to cast anything because all doubles can technically still be integers. But once we create a double, it's going to add on the decimal of 0.0. But let's assume that this is going to be reversed. I can say double amount equals 10.5. I can then say int new amount equals amount. And we get an error here. If I hover over this, it says the required type is an integer, but the provided type is a double. Well, we can do something known as casting to make this integer accept the double value as an integer value. And to do that, we can add in parentheses and the variable type, in this case int, right before the target variable name, which in this case is amount. Now if I run this, we now see 10 in the console and not 10.5, because integers can only be whole numbers, so anything that is not acceptable, for example this 0.5, is just going to be ignored, and the whole number that is left over, in this case 10, is going to be assigned into our new amount variable right here. Now this is how you cast primitive values, and I'm going to discuss the difference between primitive and reference type values in a future video. So let's take a quick example of how to convert an integer into a string. So for example, we have an integer 10, but we want the string 10, something like this. Well, I can say int number equals 10. Then I can say string equals string with a capital S dot value of. And here we can see all the different possible parameters we can pass in. We can pass in an integer, a char, a long, a float, and so many others. And in this case, we just want to pass in a number. And then I can print out string to the console. And if I run this, we are going to see 10 as a string. Now, if I want to do the reverse here, I can say string equals 10 in quotes. I could then say int number. I could then say integer with a capital I dot parse int. And here we see we can pass in a string, and this top function is going to also return an integer. So I can pass in the string argument, and then I can print out number to the console. If I run this, we should still see 10, but now this is an actual numerical value. So if I wanted to, I could increase this by 1 before printing it. So now we see 11. Beforehand, we were converting a number to a string, so we could not increase that once it was already in string form. At this point, you should already know how a basic if statement works, but if you ever tried comparing strings with an if statement, you might notice that it doesn't work correctly. For example, let's start off by asking the user for some input. I could say enter your name, and then afterwards I'm going to create a scanner. I'll call this input, and I'm going to make this equal to a new scanner, passing in system.in. This is all pretty standard stuff that we've seen before. I could then say string user name equals input dot next line. So this will retrieve the entire line that the user has entered. Now let's say that if I enter my name as Alex, it will then say hi Alex. Of course, in a real program, we could just use the variable value, but I want to specifically do this in an if statement to demonstrate something. So I can say if username is exactly equal to Alex, I can then print out hello Alex, and I can run this with Shift and F10. I can then enter my name, and I'm going to enter the exact string we're looking for in the if statement, so Alex with a capital A. So if I go ahead and enter that, and then I press enter, we don't see anything printed to the console. That's because strings cannot be compared by using a double equal sign. If I hover over this, it says string values are compared using double equals and not equals as a method. So in order to compare strings, instead of using double equals, we can take the string, we can press dot, and here we have access to a bunch of different functions. We'll look at a couple of these towards the end of this video, but the one I want to show you is called equals, as well as equals ignore case. So we'll start off with equals. Here we can pass in another string, for example, Alex. I can run this, and I can now enter Alex with a capital A, and it will then say, hello, Alex. If I run this again, I can enter Alex with a lowercase a, and nothing will be printed. If I wanted to ignore the capitalization of either string, then I can say equals ignore case, and then pass in Alex. So if I run this, I can now enter Alex with a lowercase a, and it'll print out hello, Alex, because it is not going to care about the capitalization of either string. So this is how we compare two strings within an if statement, but now let's take a look at a couple other examples of commonly used string methods. So I'm going to go ahead and delete all this code, and I'm simply just going to say string name equals Alex, and then within here, I'm then going to print name.to lowercase. I can then run this, and we're going to see Alex that has a capital A now be displayed in all lowercase in the console. And in a similar way, we also have two uppercase. And of course, if I run this, we see Alex in all uppercase in the console. There's a couple other functions we have, such as length. So if I run this, we're going to see how many individual characters are inside the string. In this case, it's 4. And we can actually just press a period at the end of name, and we see a bunch of other methods we can use. For example, here we can get a character at a specific index. So here I can get index 1, which should be a lowercase l. If I run this, we can confirm that in our console. Here we see a lowercase l. Going back, we have a bunch of other options. For example, we can concat, which means concatenate, basically adding on an extra part of a string. So I can add on my last name here. And if I run this, we now see Alex Flores. And the space that is added in the console is because of the space I added right here. By default, it won't add any spaces. It'll only do exactly what you tell it to. So feel free to mess around with some of the string functions here. There are a number of useful ones that you can actually use to change the string or to use the string in different ways. This video is going to be a little more advanced than previous videos. We're going to learn about primitive versus reference type variables and how certain variables are stored in memory. So I'm going to minimize my project right here so we have more room for these diagrams. Here we have the stack and here we have the heap. These are two different places where information can be stored in your computer's memory. Let's start off by talking about primitive type values. For example, I could say int number equals 10. This is known as a primitive type value. Typically store basic pieces of information. All primitive type values are stored directly on the stack, and this goes from the bottom up. Other examples will be Boolean. I could say is programming equals true. I could then have char letter equals a. I can have a double. I can call this pi and set this equal to 3.14159. And these are the main primitive type values that you're going to see. So let me go back and let me delete a couple of these and let's go back to our number. But what happens if I were to assign number 2 equal to the value of number 1? For example, number 2 equals number. Well, this will actually still create an entirely new value on the stack. So now number 2 equals the value of number. So what would happen if I were to modify the value of number? Would that affect number 2? Well, I'm going to print out number. And then on the next line, I'm going to print out number 2. Before this, I'm going to say number equals 15. And what's going to happen here is because these are two separate values, number 2 is not going to be affected at all. So this will print 15 and then 10. To prove this, I can run it with Shift and F10. And here we see 15 and 10. So primitive types will have their own individual value on the stack. Even if we're assigning it to an existing variable, this will simply just create another variable in your computer's memory and assign that value to it. So this means line 8 is going to create a separate integer that has no correlation at all with line number 7, aside from the fact that they happen to share the same value. So that's nice, but what is a reference type and where is the heap used? So I'm going to delete all this code here and I'm going to create an integer array. I could say int numbers equals 5, 10, and 15. And this is going to create something on both the stack and the heap. But the values 5, 10, and 15 are stored on the heap. And the variable numbers is going to be stored on the stack, but this is only going to be storing something known as a pointer. Now, the exact details of how pointers work behind the scenes aren't too important when working with Java because Java handles a lot of this for us, but this will basically just point to the actual value which is stored on the heap. So for example, I can create another array here. I can call this example, and I can set this equal to numbers. So what happens here is our array values 5, 10, and 15 still only exist once in our computer's memory, and those three values are stored in the heap as an array. But the variables numbers and example are stored on the stack, but they are now pointers pointing to that array of integers. That means if we modify 5, 10, or 15, we will actually see that change no matter which variable we're trying to access, whether it is numbers or example. To prove this, I can say numbers index 1, which is going to be the 10 here, equals 11. I can then print out numbers index 1, and then I can print out example index 1. I can run this with Shift and F10. And here we see 11 on both cases. That's because these three values here are stored on the heap just once, and then the numbers array and the example array are just going to point to that value. Meaning we have two separate variables that we see here when writing our code, but the values are stored only once inside of the heap. And this is the difference between primitive and reference types. Reference types are going to have their values only stored once in the heap with a pointer on the stack, but primitive types are so simple that we can just simply store the values on the stack. So I can say int num1 equals 5, int num2 equals 10, and then I'm going to call an add function, which we'll make here in a second, and I'll pass in 5 and 10. So going outside of our main function, I can say public static int add, int num1, int num2, and within here I can return num1 plus num2. So what's going to happen here is when we pass in 5 and 10, it's actually going to create two more variables on the stack called num1 and num2, assigned the same exact values as the arguments that we're passing in right here. To prove this, after our add function, I'm going to print out num1 with a comma and then num2. But within our add function, I'm going to say num1 equals 10. So now if I run this, we now see 5 and 10, but we actually changed num1 equal to 10. And in fact, the sum of the add function, if I were to put this inside of a print statement, this is going to print out 20. So if I run this one more time, we see 20 in the console and then 5 and 10. So let me break this down line by line just in case this is confusing for you. We're first creating two variables that are stored on the stack, 5 and 10. We are then going to print out the sum, passing in 5 and 10. Notice how we are not changing num1 or num2 at any point at all. That's important to note when we reach line 10, when we are passing in num1 and num2 to the console. So these two variables are not changing at all. Once we actually invoke the add function, we're passing in 5 and 10, which are going to create two more variables stored on the stack, and we happen to just modify the first number, or the first argument right here, to the value 10, essentially meaning that we are adding 10 to whatever the second argument is, which in this case is 10, and that's why we get 20 right here. Now the important part here is that we are modifying the very first argument that's passed in, but this is a brand new integer. So primitive types are just going to pass in their value, and it's going to basically just be a copy of that value. Any modifications to that within the function will not actually affect it in the function that originally called it. Basically, we're our main function. That's because these are primitive types and just the value is passed in. But what happens if we pass in an array of integers? For example, we have an array with just two values. So instead of num1 and num2, I can say int numbers equals 5 and 10. I could then pass in numbers, and then I'm going to log numbers. Now we have a problem with our function. It's because we're expecting two different integers, but instead I just want to add two numbers together from a number array. So I can say int brackets numbers, then I can return numbers index 0 plus numbers index 1. So I can run this with Shift and F10, and here we should see both the sum printed out and each individual number as we see right here. But what would happen if I changed numbers index 0 to 10, which originally is 5 in this array? Keep in mind that this array is not being changed at all, and we are passing in the first element of the array into this console log right here. So if I run this, we now see 20 printed out as the sum because we're changing the first index, which is index 0, which is 5, to the value 10 right here, meaning we're basically printing out 10 plus 10. But then numbers index 0 printed to the console is now changed. That's because the reference or the pointer to that array is passed in as an argument, not the actual values themselves. So when we go to modify numbers index 0, it's actually modifying the same exact array that we created on line 5. Because we're just passing in that pointer that is on the stack, which just points to the actual values which are stored on the heap. And this is an important difference between primitive and reference types. Whenever you're working with functions, it's important to know that when you modify something as an argument, for example, int numbers right here, that it might or might not actually modify that with the rest of your program, depending on if it's a primitive or a reference type. Now, a lot of these concepts are new, and I know that this is probably one of the more confusing concepts when it comes to programming if you're new to programming. So if you have any problems, I suggest watching this lesson over again and really try and focus on the stack and the heap visual representations as I'm explaining everything. We're now going to dive into a concept known as object-oriented programming. And a short form way of saying this is OOP or OOP. And this is definitely where Java gets a lot more interesting and we can actually build some real world programs with it. But first, let's talk about what is object-oriented programming. Well, this is a concept that is not exclusive to Java. Other programming languages have this concept as well. And this is basically where we can represent real world objects within our code. And in these upcoming videos, I'm going to be explaining what further keywords meant, such as class and static, and other keywords that I mentioned I'll be explaining later on. So let's quickly take a look at what a class is versus an object. A class is basically going to be the actual code that represents the blueprint of a certain type of functionality or certain type of object. Now, when I say blueprint, I want you to think of a house's blueprint. And for example, if you ever see a bunch of houses that look similar to each other, there's only one single blueprint that they basically just copy and pasted. And each house is going to be its own object. So a house is going to be an object where the blueprint is going to be the class. So we can have many instances of each individual class, and those are known as objects. Let's actually use this house example in a real programming example. So within our main package here, I can right click, I can go to new, and then Java class. Within here, I'm going to name this house, but I'm going to be using a Pascal case notation, basically meaning that we capitalize the very first letter of every word. So if I had house example, both the H and the E would be capitalized, but in this case, I just want to create a class called house. Go ahead and press enter, and this should automatically open. And now within this class, or within this blueprint, we can add in various properties. Now, what is a property? These are basically variables and methods that are specifically defined within this house class, and they help us access different values or work with different functionality within the context of a house. So we'll be diving into a lot more detail of what would actually go into a house class over the next few videos, but first let's take a quick look at how this house class can actually be used. So within our main class here, I'm going to go ahead and delete some of these comments. I can now say house with a capital H, and here we see it's going to try and import from our local file system. I can go ahead and press enter, and then here we can go ahead and name our variable. In this case, I'll say house with a lowercase h, and I'm going to assign this equal to a new house. Now the new keyword is part of object-oriented programming and classes, but the details of that will be explained later on. For now, we could think of this as us basically just having a new house. So a house class right here, this is going to be the blueprint, but now we've actually created a real instance of our house. Let's take a very simple example by having the house print hello world. So I can say public void static in this example. So public void print. And then I'm going to have no parameters. I'm simply just going to print out hello world to the console. Now, if I hover over this, we see that the method print is never used. So let's go ahead and try using it. Going back into our main class, here we have access to this house. So I can say house, press a period. This is going to have a dropdown with all available properties and methods that we can access. In this case, we have access to our print function. I can go ahead and press enter, and I'm going to run this. And here we see hello world in the console. So I'm going to go ahead and rename this variable. I can click anywhere inside the variable name, and I can hold shift and press F6 at the same time. And now we can go ahead and change this. I'm going to change this name to my house with a capital H and lowercase m. And now I'm going to create a brand new variable. So I can say house, your house equals a new house. Now these two variables have nothing in common aside from the fact that they were created with the same class. So basically they are neighbors to each other, but they're not the same house. If your neighbor has a similar house to yours, doesn't mean that it is your house. It's just a similar house based off the same blueprint. So for example, I could say your house.print, and I can go ahead and run this. And now we're going to see two instances of hello world in our console, as we see right here. So this is the very basics of classes and how to create objects around those classes. And over the next few videos, we're going to be diving much further into object-oriented programming, where we can create a functional house object that really represents an actual house within our programs. We're now going to talk about a concept called constructors, which is basically just going to be a built-in method into every class that is ran or invoked whenever a new instance of that class is created. And there's actually a default constructor in every single class, so whether we create one ourselves or not, it's going to automatically have one. So a constructor will look something like a method, but slightly different because it is not going to have a return type such as the void right here. And also the constructor name has to be the exact name of the class. So I can say public house with a capital H, and this is now known as our constructor. To prove this, I'm going to print out a new house was made, and I'm going to run this. And in our console, here we see a new house was made because we created a new instance of our house class right here as the variable my house. And so that made the constructor be ran. We then are printing out hello world, but then we're creating another house, which means the other constructor is ran. And then of course we're printing out hello world again. Now, a constructor cannot return anything, but it can take in different parameters. For example, I can have string owner name, and then I can say a new house was made, the owner is, and I can add on owner name. Now we get two related problems right here. That's because back in our main class, we're not passing in any arguments. Then here I'm going to pass in Bob. Of course, you can add in any other name you want. So if I run this, we can now take a look at our console. And here we see a new house was made. The owner is Alex. And that's because we created a new instance of our house class right here. And we passed in Alex as a string to our constructor. And then of course, when we created Bob's house, we see the owner is Bob in the console. Now, similar to methods, constructors can be overridden. So we can pass in different types of values into the parameters. So I could say public house. I could then say int floors. Then here I could print out a new house was made. It has, I can add on floors, and I can add in the string floors. And I'm also going to put parentheses around the S because we might pass in a single story house. So now we have two different constructors, and these are going to be ran at different times. So for example, back at Bob's house, instead of passing in Bob, I'm going to make this a 2-story house. And you might notice that automatically IntelliJ is going to notice that this is now going to be the floors parameter. This is not going to be owner name like it says right here. That's because it understands that we're overriding the constructor to pass in two different types of variables, and here we're passing an integer. So that means we're going to be using this constructor right here. So now if I run this, and if we look into our console, we now see the first instance of our house is going to print out the owner is Alex, but the second instance of our house is going to print out it has 2 floors. That's because we are using the different type of constructor that passes in integers only. Now in this example, we've just printed out some text, but in real use cases, which we'll take a look at in a few videos, we're going to basically use these as setup functions to make sure everything else is set up and is going to work correctly for our house to function. We're now going to look at the this keyword, as well as how to create different properties, which are going to basically just be variables inside of our class. So I'm going to get rid of these comments here, and I'm also going to get rid of these print statements within our 2 constructors. Now, inside of our class, but outside of the functions, I'm going to create a couple different variables. For example, I could say private string with a capital S, owner name. I could then say private int floors. And the private part of this, as well as the public on some of these methods, are going to be explained in a future video. Now, I've already demonstrated how we can overload constructors, but in this case, we just want a single constructor with both pieces of information being passed in. So here I can say int floors. And now inside of this, I'm going to want to assign the new owner name and the new floors from the parameters to our local variables, because these 2 variables here are different variables than our parameters right here. But before I do that, we have 2 related problems, because if I go back, we are now using incorrect syntax for our constructors. Here, let's say my house has 2 stories, and let's say that this is still Bob's house, which of course you can use any string you want on these, but it is also 2 stories. So going back into the house class, we no longer have any problems, but how are we going to set the owner name on line 4 equal to the parameter that's being passed in? Because of course, they're the same exact name. So saying owner name equals owner name doesn't really do anything and doesn't actually modify line 4 whatsoever, because this is going to reference the most local variable in this scope, which in this case is just going to be the parameter owner name right here. Now, technically, we could change the names of these variables so they're not exactly the same, but that's not the most correct solution. The most correct solution would to say this.ownerName equals owner name and this.floors equals floors. So what is actually happening here? Well, this represents the current object. So whenever this constructor is ran for my house, which has the owner name of Alex and 2 floors, the this keyword right here is going to reference the my house object right here. And when we're creating Bob's house, the this object right here is going to be referencing the your house object right here. So the this keyword right here is going to represent the current object that is being used for this class. To prove this, within our print function, I can say this house is owned by, I can then print out this.ownerName, and it has plus this.floors floors. Of course, I'll put parentheses around the S just in case you want to pass in a single story house. Now we're still using this print function, as you can see right here. So I'm going to go ahead and run this program. And here we see this house is owned by Alex and it has 2 floors. We also see this house is owned by Bob and it has 2 floors. So the names and the number of floors are going to be saved locally right here. We are not accessing the parameters that we added in right here because these are bound to only be accessed within the constructor's scope. So basically we have our own parameters or our own variables within this class. We're assigning those whenever we're creating the object from the constructor. And now we can access these variables anywhere within this class of floors. Now, technically in this use case for the print function, the this keyword is optional because by default, it will assume that we're going to use the current instance of the class. So I can go ahead and delete these. And if I run this again, it's going to work the same exact way. Now, technically, this is not good practice because saying this.ownerName and this.floors makes it very clear that we're trying to access variables stored in the class, but it is technically optional in this case of the print function. But our constructor has these to be required because it has the same exact variable names as our parameter. So to be very clear which values we're assigning to what variables, we can say this.ownerName to reference our local private string here, and this.floors to reference our local private integer here, and then assign those to the ownerName parameter and the floors parameter. Let's take a look at something known as inheritance. This is basically where we can add on or extend another class to give it more functionality. For example, I can make a new Java class and I'm going to call this hotel and I'm going to extend house. So I can say extends house. So what this means is it's going to inherit all of the functionality within the house class, but then we can add on more functionality inside. For example, we can now specify a lobby square footage or the number of staff, things like that that a hotel has that a house doesn't have. But a house is still going to have an owner and a certain number of floors, which a hotel also has. So instead of making a hotel class, which would have these properties inside, we're just going to extend house, which already has these properties. That way we don't have to actually make them again. But we're getting this error here. If I hover over it, it says there is no default constructor available. So if we go over to the house, we see that there is no default constructor, meaning that there is no constructor that has 0 parameters. So we have these 2 parameters right here of the owner name and floors. And that means that our hotel, which extends house, also has to have a similar constructor. So I can say public hotel, string owner name, and then int floors. Now we get another error. If I hover over this, it says there's no default constructor available. This means that we have to use something known as the super method. So if I call super here, I can then pass in owner name and floors, and the super function is only going to be used within classes that extend another class. This will basically just call the constructor of the class we're extending, in this case house. So now we've created a hotel constructor. This is going to call a constructor of the house constructor. Therefore, we are going to set the private properties of owner name and floors equal to the properties we are passing in. And in this case, we're simply just going to pass those in from the hotel constructor. Now, if this seems confusing, don't worry. Let's go ahead and make a new hotel instance, and it'll make a lot more sense after that. So here in our main class, I'm going to say hotel, my hotel equals a new hotel. We can then pass in the owner and then the amount of floors, let's say 10. I can now print out my hotel dot get owner name. But inside the hotel class, we don't have an owner name at all. That's because we are still extending the house class, so it inherits all the previous functionality inside of this class. For example, get owner name. So of course, if I were to run this, it would just simply print Alex to the console. I'm not going to bore you with that simple concept. I'm sure you understand that. But let's dive further into how these constructors work and how the super method works. Basically, I'm passing in Alex and 10 as parameters into the hotel constructor. So therefore, the owner name and floors will be Alex and 10. We are then calling super, which is going to call the constructor of the extended class. In this case, that is house. So essentially, we are going to call this function right here, which will set these 2 private properties equal to Alex and 10. Now we can access these within hotel if they are public or something that is known as protected. So far we've seen private and public. There is also another one, which is protected. So for example, inside the constructor, I cannot print out this.ownerName. We see in the dropdown here, there is no option. And also if I just leave it like this, we're going to get an error. If I hover over this, it says owner name has private access. That's because the private access means that only things directly in this class can access it, not necessarily things that extend this class. If we wanted the extending classes to access it, we can change private to protected. Now the error goes away, and protected basically means that anything inside the class can use it, as well as any classes that extend this class can use it. Let's now talk about a concept known as polymorphism. This is basically something that means many forms, because poly means many, and morphism means forms. So to take a look at the problem that polymorphism solves, here we have the myHotel object, as well as the yourHouse object and myHouse object. These two are using the print function, and because the hotel extends the house, we now have access to the print function. So I can say myHotel.print. Now if I run this, we see that the house is owned by each person and it has so many floors, but the hotel still says the house is owned. So we want to basically override the exact functionality for the print function within the hotel class. To do this, let's take a look at the house class real quick. Our print function says public void print. So our hotel class needs to have the same exact function. I can say public void print. And now for simplicity, I'm simply just going to copy and paste the previous line here. I can use Control-C on Windows or Command-C on Mac. And then I can go ahead and use Control-V on Windows or Command-V on Mac. Now we get an error because these two properties are private and they're not protected. So I need to use their corresponding getters. So I could say get owner name. And we don't have a get floors method yet. So if I say get floors, it doesn't actually exist. So let's go ahead and make one. This should be pretty simple. I can say public int get floors. And within here, I can simply just return floors. So now we have a getter that we can use. So within hotel, we no longer have an error here. So we can change the house is owned by to the hotel is owned by. Now if I run this and we look at our console, here we see the hotel is owned by Alex and it has 10 floors, where the previous house objects still say house. So this is what polymorphism is. We have many forms of the same exact function. So here we have a print function in our house, and here we have a print function in our hotel. And whenever we're trying to access a print function, we're always going to use the closest one to the exact class. So for example, now that we have this print function, it'll use this, but beforehand it didn't have it, so it would look to the house class, which we are extending. And of course, house did have a print function, so it would then use that. Now this is also known as a concept of method overriding. Now this is not meant to be confused with method overloading. This is where we have two methods of the same exact name, but perhaps different parameters. For example, I could say public void print, and as an argument, I can say int times. And here I'm going to loop through a certain amount of times depending on how many times it's passed in. So I can say for int a equals 0, while a is less than times plus a. Now within here, I could just copy and paste this line right here, or I can just simply call the print function. So now going back to our main class, we are simply printing this, but we also can say myHotel.print and pass in 5. And now I can run this. And here we see it is printed out 5 different times. Now, of course, we see 5 times right here, but we also have the 6th time we created. Now, we've already gone over method overloading. This isn't really a refresher. This is just to clarify that method overriding is different than method overloading. Obviously, they can get confused because they're similar words, but they are a different concept as you can see here. So far, we have different properties within our classes, for example, owner name and floors, and these are going to be tied to each individual object that we create. For example, my house, your house, and my hotel. I'm now going to introduce a new keyword, which is the static keyword, which you might see right here. And this basically is not going to tie those properties to the individual objects, but rather tie those properties to the class itself. Now, every single house is different, so it's hard for me to describe a static example when it comes to houses, so we are going to use birds instead. So I can right-click, New Java Class, and I'm going to name this a bird. Now, let's say that each bird is going to have its own name, so I can say private string type, and then here I could say public bird as a constructor. We can have a string in here called type, and then within the constructor, we can assign the local variable type equal to the parameters passed in from the constructor. So here I could say this.type equals type, and everything seems pretty basic so far. Let's go into my main class, and I'm going to comment these out. We will uncomment them in future videos when we go back to the house example, but again, static is much easier to understand and for me to explain without using houses. So here I can say bird equals new bird. So I have access to a bird, but now I have to pass in a certain type. So for example, I can pass in a crow, and now we have access to a bird. Everything seems pretty standard so far. Now, static properties, such as variables and methods, come in once you want to bound something to the class itself. Like I mentioned, the house has the owner name and floors that are bound to each individual object created from this house class. So in our main file here, we have my house, which is going to have its own properties of owner name and floors. And then your house will have different properties, also called owner name and floors, and my hotel will have the same thing because this is extending the house class. But if I go into bird, here I can create something known as a static variable. So I can say public static int wings equals 2. Now if I go back into my main file here, when I go to access bird.wings, we see it doesn't actually exist. That's because, again, the static variables are not tied to the object bird itself, the object being this object that we created right here. Instead, they are tied to the actual class, so bird.wings. So now if I run this, we're going to see the amount of wings that this bird has. In this case, it is 2. But why use static here instead of just making a normal variable? That's because this is only created one single time. And otherwise, for example, with string type, this variable here is created each time we make a new instance of our bird class. Going back to the house example, we have 3 different instances of owner name and floors because we have 3 different objects that are going to use them. But if I had 3 different birds, we would still only have one integer called wings. So static variables like this one here are going to be used whenever you have a class that has a shared piece of information. So for example here, birds have 2 wings, and that's never going to change. So having it as a local variable such as private int wings equals 2 doesn't make too much sense because this is never going to change. So therefore, we don't need to have a wings variable tied to each individual object we create. Instead, we can just tie it directly to the class. Now we can also have static methods. So I can say public static int get wings, for example, and here we can just simply return wings. Now typically, static methods are only going to be used whenever you're trying to access or use static variables for some type of functionality or to return things such as a simple getter right here. So now in my main class, I can now print out bird.getWings. And of course, this will have the same result because we're just simply returning the same variable. But similar to the variable, bird.getWings doesn't actually exist because, again, static properties and static methods are tied to the class, not tied to the object created from the class. What if you want to check certain types of classes against other types of classes? For example, I'm going to start off with the code I left off with in the last video, but I'm going to get rid of all the print statements right here. So we just now have a crow and a robin. I can now have an if statement saying if a crow is an instance of a bird. I can then print out a crow is a bird. And here we get this warning. If I hover over it, it says condition crow instance of bird is always true. And that's because this crow right here is just a variable that we created, but we're never changing it at all. So it knows for sure that this is an instance of a bird because crow extends bird, as we see right here. Now, of course, if I run this, it's going to say a crow is a bird, as we see right here. But this also can be done with interfaces. So a crow is an instance of an animal. Now, if I run this, we're going to get the same exact response, as we see right here. Of course, technically, we should change the sentence to say a crow is an animal, but you get the idea. So instance of can be useful if you want to check if a certain object is an instance of another class or an interface. And this is one more use case for interfaces because technically you don't necessarily have to have anything inside of your interface and it will still work. For example, a robin is still implementing animal and the crow is still implementing animal. Average lifespan now just becomes a normal method that is attached to the crow class and attached to the robin class respectively, and has nothing to do with the animal interface. But now that a robin and crow are both animals because we're still implementing the interface, we can still use them in checks like this. We're now going to be moving away from object-oriented programming and moving into other aspects of Java. For example, in this video, we're going to learn about enums, which stands for enumerations. Basically, these are specific types of values that are kind of like variables, but they cannot change and they can be used in very specific ways. So let's go ahead and make a new file here. So we can select Java class, then here we can select enum, and I'm going to call this days of week. Now you can have enums that have whatever values you want, but typically these are going to be things that should never change. So they're not technically like a variable where you could have input from a user or some type of random number. These are the things that are going to be concrete and always used in the exact same way. So a good example of this is the days of the week, which will not change. So here I'm going to add in Sunday, comma. I notice how I'm typing in all uppercase. This is a common convention when actually using enums. So then we can have Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. Obviously spelled correctly. So now we have these 7 different values within our enum, but how do we actually use them and how are they useful? So going back into our main file, here I can say days of week dot, and then I can access each individual value if I wanted to, or I can get all of them as an array. Here we see the values method is built into enums and it returns days of week as an array. But for example, if I wanted to print out days of week dot Friday, I can then run this, and here we see Friday in the console. We can also use these within if statements. Now each individual enum value also has a set of different methods. For example, we can compare it to another instance of days of week. We can get the name, we can get the ordinal, and let's take a quick look at these two things. So I'm going to print out the name, then I'm going to copy and paste this line, and I'm going to print out the ordinal. Now if I run this, here we see Friday again, and then 5. 5 is going to be the actual index that this is used. For example, Sunday is 0. Now you don't have to add in these comments. I'm just doing this to make it easier for us to actually read this. So here we have it 0, 1, 2, 3, 4, and 5. And of course, Saturday would be 6, but this is why we see 5 in our console. So I'm going to get rid of all these, and now let's expand on this enum. For example, let's say I don't want Friday to be in all uppercase, but rather I want to provide a specific string as the name of that day. So similar to classes, enums can actually have their own constructor. So I'm going to put a semicolon at the very end of all my values. In this case, that is Saturday. And then here I can say days of week. Now you might notice I don't have public or private or anything like that here. That's because if I hover over this error, it says public modifier not allowed here. The reason for that is this constructor function right here can only be ran within the enum itself. So for example, within Sunday parenthesis, here we would pass in different arguments into the constructor. We cannot access this constructor outside of this enum file. But why would we need a constructor in the first place? Well, we can actually store different values for each individual enum value, similar to private properties of a class. So I can say private string name. I can say private Boolean workday. And then within the constructor, I can require these two properties. So string name, Boolean workday. Then I can say this.name equals name, and this.workday equals workday. Now we get some errors on each of our values, and that's because by default, it's going to call the constructor with no built-in arguments. But of course, if I hover over this, it's going to expect a string and a Boolean. So here I can pass in Sunday, and then I can say false for it being a workday. I'm going to do the same thing for all of these. So for example, Monday and true. I can say Tuesday and true, Wednesday and true. I can then pass in Thursday and true. Here we have Friday and true. And then finally, Saturday and false. So now we have no more errors, and let's try and use one of these within our actual file here. So instead of daysofweek.friday.name, can I access the actual values such as weekday? And we can't. We actually have to make our own public getters in order to do that. So here I can say public string get name. I can now return name. And then I can say public Boolean is workday. And I can now return workday. Now getName is not a really good name for the method. The reason for that is this can be easily mixed up with name. So for example, we have name and getName. It's very unclear which one does what we want. So one thing we can do is we can rename this to getDisplayName. Now, a display name is something that typically is going to be shown to users, so something with a uppercase F and lowercase everything else would be a better display name than everything being in uppercase. Everything being in uppercase looks weird to the user, and so a capital F with everything lowercase is actually how you would say this normally, so this will be a proper display name. So going back, instead of get name, I can now say get display name, and then of course, here I'm going to say Friday.isWorkday. Now I can go ahead and run this. We should see the display name as well as if it's a workday, which in this case it says Friday and true. Now you can actually use enums as variable types. For example, I could say days of week, day equals days of week dot Monday. I could then say if day dot is workday, I can print out going to work today. Otherwise, I can print out it's a weekend. So now if I run this, we are going to see going to work today because we are accessing the value day, which equals Monday. But of course, if I change this to Saturday and I run this, we now see it's a weekend. Now there's just one more thing I want to show you with enums, and that is the ability to loop through all of them. So I can say for days of week, day, and here I can pass in days of week dot values. If I hover over this, we see that this returns an array of days of week. This will be an array of each individual value as its own element. So within here, I can print out day.getDisplayName, then a colon, then I can add on day.isWorkday. So if I run this, it's going to loop through every single day, and it's going to print their name as well as a Boolean if it's a workday or not. So obviously within enums, we're not receiving any external input from other parts of the program. Everything within enums are self-enclosed, meaning that the arguments passed into the constructor are just static values that are not actually variables. As you can see, I'm just passing in a string and I'm passing in a Boolean value. I'm not passing in any variables. So enums are useful whenever you have something like the days of the week, where they are concrete and never going to change. Not even the variables passed in the constructor, they are not going to change. And this is very useful if you ever have things that are very concrete like this, because then you can easily access them and reference certain values without worrying about them ever changing. We're now going to be diving into the final project for the course, and that is going to be making a single player battleship game. So here we see this board, and we have 5 different types of ships, and they're all randomly positioned around the board. We can then enter a coordinate, for example, A0, which is actually empty, as we can see right here, and it will then say miss. But I can select H0 for this coordinate right here, and it will then say hit, and this is now replaced with an X. If I do I0, and then J0, it is then going to say you sank their battleship, and this entire ship right here is sank. Now, unlike previous videos in the course where we wrote code together, during this project, we're going to be working on the plans for each individual feature together, and then I want you to try and make that feature on your own. Now, once you've completed that feature, or once you feel like you've done as much as you can and you still need additional help, you could then go to the next section of the video where we will actually be building it together. But I highly encourage you to try each individual part of this project alone before watching the step-by-step tutorial. This is how actual software developers work, so it's a great habit to get into. That way you can build the skill of problem solving using programming. To start the project, I would delete all the files you have in your project aside from the file that has your main function. I would then create these 5 different files here, and keep in mind that Battleship is my main file. This contains my main function right here. Now, there's a lot of pieces within this project that rely on each other. For example, if I hover over my main function here, I'm creating a player object and I'm creating a board object. In order to make things step by step, we want to start with the smallest possible piece that is going to not depend on anything else and is also going to be used in various other places. So in this project here, that is going to be a coordinate. Now I mentioned that you should write everything yourself before actually following along, but this file is very simple. So I'm just going to run over this file real quick with you. And in future videos with this project, you're going to want to try things on your own before you follow along step by step with my own explanations. So here we have a coord class, which stands for coordinate. This is going to represent an X and Y value on the board itself. And we're also going to have a Boolean property, which is going to represent if this has been hit, therefore meaning that a ship is there and we actually guessed that coordinate. Now, when we create a coordinate, we're simply passing in X and Y through the constructor, and we're assigning it to the local variables here. We then have a getter and a setter for all 3 private properties, the X, the Y, and the isHit Boolean. So essentially we're able to get the X, get the Y, see if this coordinate is hit, as well as set those individual values as well. Now here we have a toString function. And whenever we print an object to the console, it's actually going to run the toString function behind the scenes. So essentially, if we were to print out a coordinate, it's going to print out X, comma, Y. Now, just for clarification, in case you don't know what a coordinate is, each individual cell here is going to be its own coordinate. For example, this is B0, this is A1, and so on. We are eventually going to create our own board here, where different ships are randomly placed, and the board columns are represented from the letters A through J, and the board rows are represented from the numbers 0 through 9. Now, this X and Y value is going to represent where they are, depending on the columns and rows, and the hit value is going to represent if this has been an actual hit, so therefore you've guessed where a ship is. So here we have C5, for example, for this cell right here. If I say C5, it's then going to change to an X, and so therefore this coordinate in my program has the hit value changed to true. Let's now create our very own ship, and before you actually write any of the code yourself, I highly suggest that we actually look over the plan for this class and exactly the tips that I've given here. So what exactly is a ship? Well, obviously within our program here, if I open it up, this is going to represent an actual ship, where here we have 4 different coordinates. In this situation, we have 5 different coordinates. This one's a smaller ship with just 2 of them, and there's in total 5 different ships. So if we look at this class, the first thing we see is a private list that's going to hold a number of different coordinates. Now, of course, this is the class that we wrote in the last video, as we see right here. And each ship requires its own list of coordinates, so we know exactly where they are. Now, we also see all possible ship sizes right here, and keep in mind that every comment I add in, such as this one right here, or this block of comments right here, is designed to help you as much as possible and give some useful information of what's inside these functions. But here we have a static method that returns an integer array. This is basically just going to return 5, 4, 3, 3, and 2. And if I go over to my program and I run it again, here we see a ship that is 5 long. Here we see a 4 long ship, but it's just vertical. Here we see a 2 long, a 3, and then another 3. So if I were to add in a 6 long ship, and then I run this program again, we now see it right here. So this is going to determine how many different ships there are and the sizes of each ship. So keep that in mind moving forward. By default, I have 5, 4, 3, 3, and 2. Now next we have the constructor, and because this is only 1 line long, I can't really hide the functionality from you, but obviously it's very simple. We're just receiving a list of coordinates, and we're assigning that to the local coordinates list right here. And then we also have a getter for both the coordinates and the amount of coordinates we have. Basically, get size is going to get the size of the ship, as it kind of describes by the name, meaning that right here, this 3 will return 3, this 2 will return 2, and so on. Now these are probably self-explanatory, but the next few ones might not be. And again, I highly encourage you to take a look at the different comments I added in. For example, this is getIndex, it returns an integer, and it takes in a coordinate. And if you remember correctly, an index is where a certain element is within an array or a list. And this starts at 0. So here the description is, this returns the index in the coordinates list where the param coord was found. So this is the parameter coordinate, and we're referring to the coordinates list right up here. Now scrolling down further, we see that this returns the index if it's present, or it returns -1 if it is not present. So if you cannot find the index, then you want to return -1. Now next, here we're going to see if this is already in use. So here it checks to see if the coordinate is within the ship, and here's a tip, use the getIndex method. Essentially, getIndex should return -1 if it is not in use, or it should return something else if it is in use. And then here we have a more complicated function, which is it checks to see if the given coordinate would be a hit. Now the complexity from this function comes from it returning a Boolean array. This array is going to hold 2 different values. The first one is going to be a Boolean true or false if it was a hit, and the second one is going to be a Boolean true or false if it sank the ship. So for example, if I guess something and it's a miss, we'll have false and false. So here we'll say miss equals false and false. If it's a hit, but it does not sink the ship, it'll be true and false. If it does sink the ship, then it's going to be true and true. So these are the possible return values when it comes to the functionality. And this is all the functionality that a ship has. So go ahead and pause this video and try and add in as much of this as you can. try and get as far as possible. And once you've completed everything, or you've tried your best and you really just need extra help, then go ahead and resume the rest of this video and I'll go over my solution for how I made the ship. Alright, so starting at the top, here we have a get index. This is the first hidden method that I did not go over yet. So let's review what this is trying to do. Here we have a coordinate argument, and we're trying to see where exactly this is within our coordinates array, which is stored locally on this class near the top right here. So essentially it'll return an index, or it will return -1 if it cannot find it. So we're going to start off by looping through each individual coordinate within our list. So we're saying int a equals 0, while a is less than the coordinate list size, we're going to increase a pretty standard for loop. Within here, we're going to get our target coordinate, and this will change depending on each iteration of the for loop. We're then simply just going to check if the x value equals the target x value, and if the y value equals the target y value. If both of these are true, then that means this is the same exact coordinate, and we want to return the current index, basically just returning a. Now, if this statement is never true, then we're eventually going to break out of this entire loop, and therefore we're going to start just returning -1, meaning we could not find it. So this would be the getIndex function. Now let's move on to the inUse function, which basically just use the getIndex method. So here we're creating a boolean called isInUse and assigning it equal to getIndex passing in coordinates is not equal to -1. So -1 means that nothing was found. And if something was found, then that means something between 0 and the total number of coordinates would be returned. So basically, if the index is not -1, that means it is in use. Now we can actually simplify this code. I wrote it in 2 separate lines just so I can minimize this, because single line functions cannot be minimized. As we see right here, if I minimize this function, we still actually see the code. So going back down, to simplify this code, I can just simply return getIndex passing in coordinate is not equal to -1. So this will return true or false depending on if this coordinate is in use for the ship. And then here we have the more complicated function, which is didHit. And again, this returns a Boolean array where the first Boolean value is going to be if it was a hit, and the second Boolean value is going to be if it sank that ship. So if I expand this, here we're first going to get the index from our getIndex method. And if the index is -1, that means that this is a miss. So therefore a miss should return a Boolean array with false and false, as we see right here. And here we see this -1, which is going to be the same exact -1 that is returned if we can't find anything. Now after that, once we get to this code here, we know that we actually hit something. So now we need to see if we actually sank that ship or if it's just a normal hit. First, we're going to get the coordinate at that certain index, and we're going to set its hit value to true. If you remember in the coordinate class, here we have this Boolean hit, and so we're now assigning this to true because we did actually hit that part of the ship. Now going back into ship here, I'm going to create a Boolean called sank and set this equal to true, essentially meaning that by default, we're going to assume the ship sank. And then here, we're going to loop through every single coordinate of the ship. If it is not hit, then we want to say that sank equals false, and we're going to break out of this loop. So essentially all this code does right here is to see if the ship has any coordinates left that are not hit. If every single coordinate of the ship is hit, then the ship will then sink. And then finally, we can return our Boolean array. At this point of the code right here, we know that it was an actual hit, so the first Boolean is always true, but the second Boolean is going to be true or false, depending if it actually sank the ship, depending on this logic right here. So this is going to be the didHit function, and this is probably the most complicated function in the ship class, but hopefully all this explanation made sense to you, and hopefully you got most of this functionality down. Now, of course, in programming, there are many different ways to write this same type of code. So if your code achieves something similar to what mine does, and if it works, then don't worry if it looks slightly different. That's perfectly fine as long as it still does the same thing. This will be the last video on the Battleship project. Within this video, we're going to create our board class and our Battleship class. So let's start with the board class, which we are making a new instance of within our main function. And here we are passing in the board size, as well as the player, which we have already created. So now in the board class, I'm going to go over some basic functionality, and then I'll go over the concepts behind these different functions here, so you can go ahead and try to make them on your own. And once you get stuck, or once you complete the functionality, you can then see how my solutions look. So starting off, we have an integer for the board size. This just simply comes from the actual parameter. Then we also have a multi-dimensional character array. this is going to be the actual board itself. For example, this is index 00, index 01, index 10, and so on. Then we have a letters list, which is all the different letters for the column identifiers. So basically all the letters we see right up here. That way we don't have 00 as a coordinate or 10 as a coordinate where it's unclear which one is the columns and which one is the rows. Using letters makes this very clear which one is the columns and rows. Then we have access to a player here, which also we are just getting from the parameters, and so we're just assigning it right here. We are first creating a game board, which we'll take a look at here in a moment, and then we are going to place the ships. So for creating the game board, this is going to fill each coordinate with the board with a certain space character. So for example, board index 00 equals a space. Now, of course, you shouldn't manually assign each one of these. This should be done through a for loop. Now, moving forward, here we have place ships. This is going to loop through player.getShips. And to review that real quick, under get ships right here, this just simply returns a list of all the ships attached to this player. So we're going to get all the ships for the player, and then we're going to get the ship's coordinates in order to get the X and Y values. If we go into the ship class, here we see get coordinates, and this just simply returns a list of all the coordinates associated with that ship. We're then going to assign the ship size as the character in board X and board Y. So for example, here, this 5 long character, each individual board index, for example, this one, and so on, are called 5 because this is the 5 long ship. Over here, this is the 4 long ship. Here we have the 3 long ship. So the characters are going to be how big that boat is. That way it's very clear where the boat starts and stops. And here's a tip, an integer will count as a character, but not in the way that you want. You need to convert ship.getSize into a string with string.valueOf, and then access the first character of the result. The reason for this is because every single individual character is going to have a number associated with it when it comes to its ASCII value, which is going to basically just be a table of what each individual character on your keyboard represents in a numeric value. You can go ahead and Google ASCII value or ASCII table to get a better understanding of what I'm talking about. But with this said, you need to make sure that you're actually converting the ship size into the real number you want, because by default, it will not represent the real number. But basically, this means that ship.getSize is going to return a number that you're not expecting, and so you need to convert it into a string first with string.valueOf. Here we're going to get the letter index, and you can actually see this function here because it is only 1 line long, but let's go over it real quick. Here we're going to return the numeric value for each letter in the letters array. So we're passing in a certain letter here, and this is the letter to get the index of, and we're going to return the index of this letter from the letter array that we defined right up here. So for example, A would be 0, and so on. Now next, we're going to attempt to hit a certain coordinate. So this would see if a coordinate would be a hit or not. We're going to pass in the X and Y value of the coordinate, and it's going to return a string. If we missed, it will return miss right here. If we hit, it will return hit right here. If it is a hit that would sink a ship, it would instead return you sank their battleship. Now finally, here we have toString. Whenever we're printing an object to the console, the toString function is going to be called, so we can override this method to make it so whenever we're printing the board to the console, that we're going to print exactly what we want, which is going to be the full board as we see right here. So this is printed because of our battleship class. Whenever we're running the game loop, we're going to print out the actual board, but we'll cover that here in a moment. So this is going to loop through all the board coordinates and print the correct characters where they should be. And a tip here is to print the column labels first, which is the letters, as you can see right here. Then print each row one at a time, starting with the row number and then each coordinate for that row. So we're going to just print out the row number, and then we're going to go through and add in each individual coordinate. And keep in mind that these lines right here, also known as pipes, are by holding shift and pressing the backslash button, which is right above enter. Then I have a space. Then I have the actual content for that individual coordinate, then another space followed by more lines. So this function here is going to return a string that represents this entire board right here. So this is going to be the entire board class. Go ahead and try and make as much progress on this as possible, and then come back and see my solutions. And then afterwards, we'll go over the concepts behind the battleship class, which just has 2 main functions. But for now, go over the board functionality and try and make as much as possible. All right, so hopefully you were able to add in the functionality for the board class, or you were able to get as far as you possibly can. Let's now go over my solution for how I implemented these functionalities. So here we have create game board. If I expand this, we're going to loop through each individual array of the board. So each individual row is going to be a nested array within the multi-dimensional array right here. I'm then going to fill this entire row with a space. And if you created a nested loop to go ahead and do this, that's perfectly fine as well. Like I've mentioned before, there are multiple different ways to solve each problem when it comes to software development. So if you wrote this code, that's fine. If you wrote code similar to it that still works, that's fine as well. Next, we're going to look at place ships. So if I expand this, we're going to loop through every single ship that the player has, and then we're going to loop through each coordinate of that ship. We're going to get the X and Y value from that coordinate, and we can then assign board index X, index Y equal to this expression right here. And this goes back to what I was mentioning of using the ship size passed into string.valueof. That's because we're looking for a specific character, and each individual character has its own integer value. And because this is a character array, we cannot simply just assign an integer to it because each individual character on your keyboard is represented by a specific integer, and it will assume that that is going to actually be the case. For example, the character 0 is represented by numeric 48. The character 1 is represented by numeric 49, and so on. So what we want to do is make sure that we are actually using the correct string. So we're going to take the ship size and pass it into a string. But of course, this gives us a string variable when we want a character variable. So we can simply just access the char at index 0, which there's only one index because this is only a single digit value. But basically, this will convert the ship size of 5 into the character 5, and then assign that to the correct board position right here. So this will go through all the ships and basically just place the 5s where the 5 long ship is, the 3s where the 3 long ship is, and so on. Now moving forward, here we have get letter index, which was covered earlier on. It's just a single line of code. So moving forward again, here we're going to attempt to hit a certain coordinate. So first we're going to create a coordinate with the X and Y value, and then we're going to loop through every single ship for this exact player. If you remember from the ship class, we have a did hit function. If I go over to that, here this is going to return a Boolean array where the first value will be if it was a hit, and the second value is going to be if it sank the ship. So false false means it was a miss, true false means it was a hit but it did not sink that ship, and true true means that it did hit and it did sink that ship. So going back to my board, here I'm going to get access to all the hit data, and then I can create two separate Booleans where did hit is index 0 and sank is going to be index 1. We're then going to see if hit is true. If so, we're going to X out that specific coordinate. So for example, if I run the program, here I can select B1 to represent this right here. So I can enter B1 and it changes that 3 to an X because that was an actual hit. And it also returns the string hit right here. So in order to do that, here we're going to return if it sank using a ternary operator. We're going to return you sank their battleship, but otherwise we're going to return hit. And this is actually where the string comes from that we see in our console right here. Now after this for loop, if nothing actually matched, that means that it missed. So we're simply just going to return the string miss. So moving forward, here we have a toString function. This is basically just going to print the entire board to the screen. So we're going to use a string builder class, and there's nothing wrong with using a normal string and just adding onto it. They're basically going to do the same thing. But I'm using a string builder, which basically just allows me to add more things to the string in a cleaner way. But behind the scenes, it's basically just adding onto a string. So here I'm starting off with these extra spaces because if I go to my program, that's what we see right here with this highlighted text. This is the starting spaces to make sure that the column labels are lined up with each individual column. Then I'm creating something known as a delimiter, which you can kind of think of as a separator. And this will be a space followed by a pipe followed by another space. And that's what we see right here in between each individual character for that exact coordinate. Then I'm going to add in a comment. I'm going to say that this is going to be adding on the columns. So I'm going to loop through the board size. Because boards are always a perfect square, I can loop through the board size 2 different times, one for adding the columns and one for adding the rows and the individual content. So here I'm going to append letters.get a, which will start at 0 and loop through the entire board size, which is why we see this right here. So I can now loop through this entire thing. Next, we're going to append the delimiter to the actual string, basically adding on the space, the pipe, and the extra space. But we do not want to do this when it comes to the very last element here. As we see, J does not have an extra line at the end of it. So to check this, we can say if A is less than border size -1. If I were to change this, and I were to run this one more time, we're going to see an extra line on the edge of J, which I don't really like, but that is up to you if you want to have that. So I'm going to change this back to what it was. And now moving forward, after we've added on all the columns, we're going to add on a new line using the /n escape character. So from here, it's then going to go to the next line right down here. Now here we're going to add on each individual row and the actual content for the board. So essentially we're going to have a nested for loop, looping through it basically twice, one for the X values and one for the Y values. So inside of this nested for loop, we're then going to have A and B, which basically can represent X and Y. In fact, to make things easier, I'm going to click near A, and I'm going to press Shift and F6 and rename this to X. And then I'm going to do the same thing with B, Shift and F6, and I can change this to Y. Now this makes this more clear when we're accessing the board values. We're basically just looping through the entire X and Y coordinates for the possible values. Now one thing we want to do is when Y is 0, that means we're at the very start right here. And so we want to add on the row number, for example, 0, 1, 2, and so on. So we're going to add on that right here, and then we are going to append the delimiter. That being a space, pipe, space, which we see right here. Now afterwards, we're going to add each individual character. So we're going to add on the board at index X and index Y. So here is 0, 0, here is 0, 1, 0, 2, here is 1, 0, and so on. Now most of these are going to be spaces, but of course, when the ships were created, they replaced specific random characters with where the boat should actually be. Then afterwards, we're just simply appending the delimiter. That way, after we print out this space here, we have another space with a pipe and another space to create some white space to make it easier to read everything. And then afterwards, we're going to append a new line. This is going to what's taking this line right here and wrapping it down to the next row. And then at the very end of the function, we're going to return result.toString, basically just returning the string that we just created. So this is everything when it comes to the actual board and printing things out. If this was complicated for you, don't worry, that's completely normal. This project here is designed to have some easy aspects and some challenging aspects. So if you get stuck in these parts, don't worry, that's perfectly normal. But now that we have our board class created, let's go over to our battleship class and let's take a look at the final two functions we need in order to make everything work. So far we've created a player and created a board, and now we're going to run game loop passing in our board. So there are two functions, and similar to the rest of this project, I'm going to explain the concepts behind it, and then you can go ahead and see what you can do with those concepts, and then afterwards check my solution compared to yours. So here's a description of how this game loop is going to work. We're going to create an infinite loop that will do 6 different things. The first is to draw the current game board, basically just printing out this board object to the screen because we created a toString function down here. So whenever we print a board object, it's going to run this function. Next, we're going to print the last action. So this was either a miss, a hit, or they sank their battleship. So we're going to actually want to create this string that's mentioned here before our while loop. Then we're going to ask the user for coordinates, or they can input the string quit. As we can see right here at the bottom, enter a coordinate, here's an example, or quit to stop playing. So if I enter quit, it's actually going to close the program, basically meaning we're going to return from this function. Now step 4 is what I just described, quit the game if quit was entered. Step 5, now this is where most of the logic is. So step 5 is to check if the coordinate is valid, basically meaning it's going to have 2 individual characters. The first one is a valid letter that is part of this array right here. And the second one is a valid number between 0 and 9. If either of those are false, or it is not a 2-character long string, it's going to continue to ask them for the correct coordinates. For example, if I run this and I enter simply just A, it's going to ask me again. If I enter Z0, it's going to ask me again. If I enter A0, it's going to actually work. So it has to be a valid coordinate. And this is actually what we're going to do in this next function right here, but I'll describe that once we get there. So we're going to first check if the coordinate was valid. If so, we're going to attempt to hit that coordinate. Then we're going to store the last action string to print it out after the board is displayed on the next loop iteration. That's what I mentioned right here. Basically, we're going to have a string before our while loop, but we're going to assign its value once we actually have determined if it's a valid coordinate and after we've tried to hit that coordinate. That way, when we loop back to the start, we're going to draw the current game board. We're going to print the last action. That way the game board does not cover it up. And then we're going to continue on. Now afterwards, if the coordinate is not valid, then we're going to jump back to step 3, which is right here. Ask the user for a coordinate input or to enter quit. So this right here is what we're going to do to loop again and again and again if they do not enter a valid coordinate. And this is where all the parts of the game come together. Now, this function here is going to use this next function, which is valid coordinate. We're going to pass in a string, which will be the actual user input. So when I enter B5 right here, the string B5 is going to be entered within this parameter right here. We're also going to have a board. And if we look at the exact description here, this is going to check if the user input is valid. Now, there are two requirements. The first one is it must be a 2-character long string. The next one is it must be a letter, A through J only, followed immediately by a number, which is 0 through 9 only. Now, here's a tip. Input is received in strings, so getting an int value of the second character, which should be 0 through 9, will not act like 0 through 9. Instead, it's going to act like its ASCII chart values, which I mentioned earlier in this video. This means the character 0 would equal the integer 48, and the character 1 would equal the integer 49, and so on up until the character 9 equals the integer 57. So to check if the string input of the second character is 0 through 9, you actually need to check to see if its integer value is greater than or equal to 48 and less than or equal to 57. Basically meaning 0 equals 48 and 9 equals 57. So we want to be within these two values right here. So go ahead and write the functionality for this. I would suggest starting with the isValidCoordinate function because this is required for the game loop. And then once you have this done, go ahead and try and tackle the game loop. And then afterwards, you can compare your solutions to mine. So let's start off with the isValidCoordinate. If I expand this, here we're first going to see if the length of the string is not equal to 2. If that is correct, then we're going to return false because this has to be a 2-character long string. For example, if I enter B55, which is 3 characters long, it's then going to ask me again. If I enter test, which is not 2 characters long, it's going to ask me again, and it will continue to ask me again until I enter a valid coordinate, such as J9. Now, obviously this is a miss, but it actually worked. Now, afterwards, I'm going to create a character array to separate the exact coordinates into the individual characters. And the first thing to do with that information is to check if the letter actually exists. So board.getLetterIndex, as we see right here, is going to return the index from all of our letters right here, meaning that if it does not exist, it's going to return -1. This will basically make sure that A through J was used. Now, if it's not, we're simply going to return false, but if it is used, we're going to continue and move on and check the next values, which will be checking 0 through 9. So here we're creating an integer and assigning it equal to a character. Remember, array is a character array, meaning that they're going to be individual characters which have numbers that represent them. For example, the character 0 is represented by integer 48. The character 1 is represented by integer 49, and so on. So we're going to actually make sure that this is 0 through 9 by seeing if the value is greater than or equal to 48, and if the value is less than or equal to 57. If this condition right here is true, that means that everything is correct when it comes to the valid user input. So now let's scroll up and let's make the very final function for this entire project, which is run game loop. This will take all the functionality and put it together to actually be usable. If I expand this, we're going to start off by making a scanner, and we're going to create a string, which is called last action, and we're assigning this equal to null. We're going to assign this later on. This will be either the miss or the hit or the you sank their battleship string. And we're going to go ahead and make this first because we're wanting to print out the board, and then immediately afterwards we're going to print out the last action. That way it is not automatically replaced by the board. For example, if I were to print this out beforehand and I were to run this, if I enter A0 for example, the board covers it up. If I scroll up, here we see the miss. So this is why we need to create the string outside of the while loop, so it is not going to be reset each time, and we can then print it out if it actually exists. Next, we're going to create a string called coordinates, and this is going to receive the user input. Here we have a do while loop, which if you remember, basically this is going to run this exact code at least once, no matter what. Then afterwards, it will continue to run this code as long as this expression right here is true. So let's take a look at what this code inside is. Here we're printing out enter a coordinate, example A0, or quit to stop playing. We're then going to get the next word that the user enters, and we're going to convert this to uppercase, so anything like lowercase a0 would become uppercase a0, and this makes it easier for us to compare things. Now afterwards, we're simply going to see if the input was quit. If so, we're going to return from the main function, which would in turn return back here, and then just exit the main program. But assuming they did not enter quit, we're then going to see if it is a valid coordinate. And we're also going to use a not operator right here, basically meaning if this is not a valid coordinate with the chord and the board given, then we're going to continue to loop through until the user enters a valid coordinate. But if they do enter a valid coordinate, we're going to continue on and run all this code right here. Starting off by getting a character array, and this is a similar concept to what we had before with the isValidCoordinate function. We're going to get a character array where index 0 is going to be the letter and index 1 is going to be the number. So scrolling back up, here we're going to get the column, which is board.getLetterIndex array index 0. Now getting the index of this is basically going to convert A through J into 0 through 9. So the user sees A through J, but the program does not actually use A through J. We use different numbers for the actual columns, so 0 through 9. And this is actually the index of each individual character. If we go to our board, this is index 0, index 1, all the way up to index 9. So getting the index from this list is going to give us the correct Y coordinate, therefore giving us the column. Now for the row, we're simply going to take that exact character and we're going to subtract 48 for the same exact reasons as we see down here with all the ASCII examples. Basically, character 0 equals 48. So if we subtract 48, that means that any number we have is going to be a valid integer. So scrolling back up, here, the last action is going to equal board.attemptHit, passing in the row and the column, and this is going to call the attemptHit function, which would then loop through and see if the ship is actually there, and then return a string depending on if it actually hit, or if it missed, or if it sank that ship. And this is how this entire program works. So if I run this one more time, now that we see how everything works, I can now enter B3, for example, and it's going to X this out. If I enter B2, which is above it, it's going to say miss. And I can keep on entering B4, B5, and finally B6. And now it says you sank their battleship because all coordinates are now X'd out for that ship. And now we have a completely working single-player battleship game, which we built together using Java. This concludes my entire Java course for beginners. I want to thank you for taking the course. And if you want to learn more about software development from my tutorials, then check out my YouTube channel, Warren Off Keys.